Hello and welcome everybody. This video is part of a lecture series of this course, Electronics and Microprocessors, specifically for mechanical engineers. My name is Dr. Sami Salama Hussein Hajjaj and I'm going to be your instructor for this course. In an earlier video, I discussed the contents of this course in greater detail. I suggest you check out that other video and I'm going to put a link to that video in the description area. We are now in part 2, interacting with embedded systems, software considerations, and specifically we are right here on programming refreshers C++. We have already conducted all the previous sessions before. We talked about some theoretical and fundamental topics. We also conducted setup and installation in previous videos. So I suggest to go and watch those videos before you actually at this point. Now this video is going to, as the name implies, we're going to be covering a refresher on C++. This is definitely not a video for first-time people who are learning C++. If you've learned C or C++ in the past, or any language for that matter, and you would like to get a quick look into C++, then this is your video. If you're learning the language for the very first time, then actually I have a different course altogether that caters directly for those who are learning the language for the first time. Again, I'm going to put the link in the description area for that video. So today we'll be covering the refresher on C++, and specifically we're going to be covering the following areas. A little bit of background about C++ theory, and then how to get started. And I think how to get started and setup and all that stuff has already been covered, so I'm not going to do that. But we're going to talk about variables, user input, operations. Then we'll talk about loops, functions, and libraries. And finally, some tasks and exercises as we do it hands-on. So let's take a look at, so we have done this already, which is the Hello World program. If you have done C before in a previous course, then you might recognize some of the items here. If not, then don't worry about it. We will see all of those items later on. But the first thing we're going to talk about right now in C++ is variables. We mentioned this before. We said that the purpose of programming language is that to work with data. That's the very purpose of programming in general. So data comes in different forms and shape. That's why there are different types of data anyway. Even in our daily life, right, we have different types of data. You have a number that describes the temperature. You have a word that describes your grade, pass or fail. And you can also have a flag, or a condition, or a situation that describes whether you pass or fail a course. You know what I mean? So in a programming language or in software in general, this is described as variable types. And any language, by the way, any programming language will have more or less similar types that you see right here. You might notice slight differences in types, but let's go through these types. So this right here is an integer. An integer is a number that is a whole number that does not include any decimals. 4, 5, 344, -7. So it could be positive or negative, no problem. But it does not have any decimals. So any of these numbers are integers. A float is a number that has a fraction. Like it has a decimal, but up to 7 decimals. So if it's a fraction up to 7 decimals, then we call this a float. If it's a double, that's a different kind of a fraction. Now this guy has 15 decimals. And the difference between these two kinds of fractions is accuracy. Sometimes for specific applications, we want our numbers to be accurate all the way up to here. Nuclear technology, what you can say, nuclear technology, yes. Satellite technology, space program. These technologies, they require very, very, very high accuracy rates. So that is why we can go up to these fraction levels. But if it's not, if let's say your accuracy level is not really up to that level, then you can use a lower, you can use a float. Sir, do I always have to use 7 digits? No, we say up to 7. So if your number is 10.36, then it's okay. You can use a float or a double, and the rest will be 0, 0, 0, 0. It's okay. So if your number does not contain 7 digits, then either float or double will be fine. It's not really a problem. The next kind of variable is a Boolean, and a Boolean is a logical value. It has only two possibilities, true or false. So if a condition is set to true, then we give it, this is obviously true. The opposite to it is false. That's it. So these guys are described or called Boolean. These are Boolean variables. The next one is a character or a car, not char, car. And this is a single character. That's exactly the most important part about this guy, is that a car is a single individual character, one letter or one number or one symbol, but it's always one. By the way, I want to point something out here, that this 3 right here is not the same as this 4 here. Can somebody tell me what's the difference between these two? I know that the number is different, but there's a different. These are different types of variables. So the 3 here looks like an integer. So is this an integer or what exactly? If you know the answer, just unmute and talk.
It's a string, sir.
No, it's not a string. I said it clearly. This is a car, not a string. A string is right here. It's after that. Well, you are partially right. It's a text, actually, not a string. So what is the difference between them? Well, the difference between them is that in a programming language, I can do a mathematical operation on this guy. I can say 4 plus 1. That will give me a number. That will give me 5. Is that right? But if I come to this character, there is 3, and I say plus 1, what do you think is going to happen? Can somebody tell me what's going to happen? If you don't want to talk, you can just type it. What do you think is going to happen if I try to run this?
Is it error?
Yes, it's an error. It's going to give you an error. This is called an error type. And in fact, we can try it. In fact, we're going to try it in a minute. But before we do some coding, with basically the last type of character, this is basically is a character with a string, or excuse me, is a character that is a text. So although you're looking at number 3 here, but actually from the point of view of the compiler, this is essentially a text, not a number. But when you are looking at it from here, this right here is actually, from the point of view of the compiler, this is a number. So if you want to perform a mathematical operation, the compiler will allow you on this, but not on this. Because this right here is considered a text, so a text does not have or does not allow mathematical operations. You get me? And a character could be a letter, could be a small letter or a capital letter, could be even a symbol like this, the @ symbol, as long as it's a single individual character. Make sense? And the last one, the last type of variable in C++ is called the string. And the string essentially is similar to the character, but it's not, as the name implies, is a string of characters. If you know the English word string, it literally means like you're using a rope really, and you're connecting a bunch of characters together. So if you take one character and you add another character, another character, then you have a bunch of characters together, and those characters will be called a string. And this string right here is actually considered as an individual value. But in reality, to be honest with you, from the point of view of the compiler, this is really an array of characters. If this concept is a little bit confusing, you don't have to worry about it. We'll come back to it later. But in reality, this is just a group of characters. But to make things easier, we're going to call this group of characters a string. So I consider it as a variable called a string. We'll talk about what do you call this thing, collections in a minute. Now, before we let's do a little bit of coding. So let's go ahead to our compiler and let's start a new file altogether. So close everything you had. We're going to start a new file altogether. So click on new file, and the first thing you do is save it, so that you can save where do you want to put it. So I'm going to save as, I'm going to start a new folder here. I'm going to call this folder variables. So this is where you know what, let's call this week 1, because we have few weeks to work with Python. So after this, we're going to come here and write the file name. I'm going to call this variables.cpp. Okay, so now that we have a C++ program and we call it variables, and now we can play with variables a little bit. Now, when you work with variables, how do you actually work with variables? In order to work with variables, you have to do the following things. You'll have to, first of all, declare a variable. In an earlier slide last week, I told you that one of the different sources of data is that when you define it yourself. And this is how you define a variable. You declare it. And to declare a variable, you have to follow the following structure in C++. You have to declare, first of all, what type of variable it is, then the name of the variable, equal sign, and then the value itself, how much is it, and then the semicolon. So the type right here is those types that we just discussed right here, one of these two, int, float, double, boolean, char, or string. And in this exact spelling, I'm not sure if this capital or small, I forgot, I'll double check it in a while. And then the variable itself, what is going to be the name of it, and then the value. Let's do that in the program. So let's go back to our program. Let's declare a variable. So I'm going to declare int age equal 35, and save. And that's it. We have declared the variable. So right now we have declared an integer called age. So now if you want, you can write a comment. This is how you write a comment. So this is a variable called age right now, and it is an integer. Okay, you know what? Let's just do that here. It is, or no, its type is an integer. Value is 35. Okay, so this is how you do all of this information by declaring it right here in the program. You know what? Let's try. No, okay. So this is how you declare a variable. So what are we going to do with it? Let's just try to print it out. So print age. That's it. So we don't need any semicolon or like those guys right here. No, we don't need that. We just need to put age. And let's see what happens. I'm not going to run it. I want you to run it. Go ahead and run it. And I can think it's not going to work, but let's go ahead and do it anyway. Oh wait, this is, sorry guys, I'm writing Python. This is C++. This would not work at all. I forgot that I was writing Python, so my bad. So I'm going to go back. In C++ is slightly a little bit more annoying, so I'm going to go back to this program. Yeah, I'm going to start from our hello world, because we're going to need all of that stuff here. Sorry, I was writing in Python just now, sorry. So I'm going to actually now, instead of writing hello world, that's what usually happens when you work with several languages at the same time. You get mixed, and this is going to happen to me a lot. So int age 35 and semicolon. So right here again, this is a variable. You know what? Where did that thing go? Yeah, I'm just going to copy paste this whole thing. So this is a variable called age, and this is the type, and now we're going to see output the value. I mean, if you try to see output the variable, you're going to simply do this, just see out age. That's it. So let's see how that works. So compile, okay, works, build, okay, works, and then run 35. So yes. So let's see what happened here. We'll first declare the variable. Where'd that thing go? We first declare the variable called age, and then we see out, or we printed out the value age. If you'd like to be more informative, we can come here and do this. You can just come here and do this. You could say my age is, and then one more of these, and that is going to basically add them together, or concatenate them, attach them together. So compile again, build again, and then execute, and then my age is blah, 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 blah. If you want to have a bit of space in front and a little bit of punctuation, and again, compile, build, execute, and my age is blah, blah, blah. I really don't like the fact that it's right there on top, so I'm gonna have one thing in the beginning here. So what I'm gonna do right now is gonna do a little bit of cheating. So this right here, this command right here is basically telling the compiler to start a new line, simply a new line. So compile, build, execute. So there's a line, a space, an extra line. So my answer will start from here. Okay, what if I want to add more text after 35? So I'm going to come here, just do this now and say years old. And that's it. Now, that's how you can combine a variable and execute. So my age is 35 years old. Well, my real age is not really 35 years old, in case you were wondering. My real age is, what? Forgot. Born in 77, do the math. It's 40 plus, 44, 45, something like that. So yeah, so that's my real age. So let's do this again. 44 actually, yeah, 44. So yeah. And my age is 44. Okay, so that's how you declare a variable. Now notice one thing here important. This is how, the structure of how you declare a variable. You always have to begin with the type, then the name and equal sign, and then the value. That's the general structure into how you declare a variable. And regardless of the variable type, you will always, don't forget the semicolon, yeah. And you will always have to always follow this structure. If let's say I don't do this, if I just do this, age equal to 44, and immediately I have a compiler error. Because what actually says right here, and you can see what this is basically an error code. And you can see what the error is telling me. Error age does not have a type. And hopefully that could be a hint for you to tell you, oh, wait a minute, I declared this variable, but I did not define the type. Let's go ahead and define it. So I can just say int. And that will be an integer. Okay? Maybe this color theme is not clear enough. It does not show the color codes clearly. Let's just try something else. I think, yeah, this is nice. I don't like the bright colors. Ugh, okay. Yeah, I think this is fine. So what about this red line right here? Well, don't worry about it. Let's compile again, and you'll be good to go. If you compile and you still see red lines, that means we have a problem. After you have compiled and successfully run, then it should be no problem. So what about this extra space here? No problem. Even if I do this, and I click save and compile, it's still successful. The compiler really does not care about these spaces in C++. It will only count the first space only, this one. And after that, whatever space you have here, even extra lines right here, it's still going to run because C++ does not care about those extra spaces. These extra spaces we add in C++ just for the sake of clarity, to make your program easier to read. That's all. Okay, so here's what I want from you guys to do. I'm going to, right now, I want you to go to your working area, and I want you to declare a few other variable types, like those guys right here. You know what the float is. You know the float and a double are simply numbers, just like 44, but with decimals. Boolean is just set a true and false, and character, car, and string are same thing. And then after you define the variable, then go ahead and print it. That's all. So I'm going to give you guys a few minutes to do this. I'm going to also continue to do it by myself, but the difference is I'm going to stop talking, basically. I'm going to mute myself, and I'm going to play with some variables, and you guys are going to watch me, but I want you to do it with me on your side. Some of you might be thinking, oh, this is too easy. No, this is, yes, might be easy today, but this is the first step. For those who are thinking this is too easy, you are right here now. This is the very first step, and you are standing here. And you're basically watching you're learning the programming with me. This is your leg right now. And you are thinking, oh, this is very easy. I can do this. And then the next slide, when I talk about something else, oh, this is too easy. And then the next thing, when I talk about something else, the next thing, when I talk about something else, and then all of a sudden, you might find yourself here. And then you might find, okay, jumping all of these in one step might not be easy anymore. So that's why I'm saying, guys, no matter how easy you might think it is, just do the step anyway. If it's easy, just do it. It won't take you much effort, right? At the very least, you get you refresh your memory on C++, so that climbing those individual steps will be much, much easier rather than trying to jump the steps on your own, okay? Also, if you get stuck, then you can ask me questions. So I'm going to actually now pause the video, not pause the video, sorry. I'm going to stop talking, then I'll work with the variables. So I'm going to declare variables and then print them out. Of course, at any time, if you get stuck doing this, you can just unmute and ask your question or mention the problem, and then you can let me know what's going on. Otherwise, I hope you can follow along and do what I'm doing or something similar to it. Let's go. All right, so I hope you guys saw what I was doing. I was just simply, I defined a bunch of variables. You might have noticed that this is, I actually have to check this out first. Mm, uh, Invalid conversion from constant car to car. I think because of the type of semicolons that I'm using. Yeah, so for characters, it has to be a single quote, not a double quote. But for be considered a character. Yeah, for string, you have to use a double quote. I hate these things sometimes because when you write in, let's try this, compile. Yeah. So the program works. So basically, now a couple of things to notice. First of all, for the character, you'll have to use a single quotes. must use single quotes. Those guys. And not double quotes. If you have already noticed it. We have not used the Boolean in a minute, but I just want to ask a question. Bonus point or bonus question. Did I declare what's a bonus question during the semester, right? Why is this variable type right here is not color coded? We have all of these are color coded, right? Int, float, Boolean, char, but string is not color coded. And if anyone answers this correctly, I will give you now a bonus mark. Bonus means 1 mark directly added to your carry marks of the semester. Your assignment, I think your lab sheet contains 8%. So if you ask this question now, you'll get 1%. So if you know the answer to this, you can raise your hand and you can just unmute and answer. Why is the string right here is not really, and do it quickly before you Google it. This has a time limit. If you have the answer now. If you take some time to Google it, then it's too late. Why is this string is not color highlighted like the rest? By the way, if I do this, it's not going to run. It's going to give me an error because C++ does not recognize capital S string. It only recognizes this. So it does recognize a string, but it does not color code it. Why is that the case? Anyone knows?
Is it because it should be str?
No, it's not str. If I try to do this again, error. It's defined. Somebody said in the message area it's not defined. I'm defining it now, string right here. So, and as you can see, the behavior is the same. C++, the compiler recognizes it as a variable, but it's just not giving it a color code. Yes? Who is talking?
Maybe because the library is not included.
No, it is. And who said that? Marcus Chong Kwan. String is not a data type. You're actually correct. Congratulations. Even though you were guessing, but I'm going to give you the point anyway. So congratulations. Congrats, Marcus. The reason why, actually, this is sort of a weird thing to understand about C++, but I'm going to go through it now. String is definitely a variable type. Okay, let's, when you work with C and you declare a variable, or you will work with other programmers, and you tell them that this variable is a string, they will all understand what you are talking about. However, the behavior is slightly different. Why? Because from the point of view of the compiler, there is no such thing separate called a string. A string essentially is an array or a list of characters. So think of a string as a special version of character. So it's really sort of a special definition of this guy. So it's not really a new variable on its own. It's just a variable or a special kind of character or multiple characters put together in a group, and then we call that group a string. So that's why this guy right here is not really a variable type. It's actually an array type or a listing type. So we'll come to arrays in a minute. But for now, essentially, this is how why string is slightly behave differently, is because string is actually a special version of characters. Okay, kind of logical, right? That since it's not behaving like the others, it must be not a data type. But it's not exactly accurate, but I'll accept it for now. Well, string is a variable type, but essentially it's a special version of the character. We take the character, which is one individual character, and we add a bunch of them next to each other, we get a string. You got me? So now let's move on. Now, okay, working with variables, as you can see right here, okay, after you work with variables, you can do declaration, and then you can do printing out. So more or less, declare and then display. So that's not much of a work. We want to do more work of this. So that's why we have operations. Now operations we'll discuss next, but for now, I want to use the the Boolean. So how do we use the Boolean? I'm gonna jump a little bit and write an if statement. I forgot how to write an if statement in C. If statement C++. Believe it or not, I still do that, even though I've been writing code forever, because it's the surefire way of writing code correctly. You know what I mean? Without making any mistake. You don't have to guess anything. You know what I mean? You already have the structure now, and now you put the condition. So the condition is, I'm just going to put is success. So I hope by now you see why I declared this guy, or why I named the variable is success. Because most of the time when we declare Booleans, Booleans are usually described or used to declare a flag or a status, a condition, if you'd like to call it. All of these are true. So how do you check the condition? You basically ask a question, is this true? So that's why is success is actually a question. Is it successful? Something like that. So by default, I set the answer to that question as true. So just like that, you already declared the variable, and you can, when you read the code, you understand what's going on here. So if you have read my code and you read this is success, and you know, oh, this condition or this Boolean checks whether or not successful or not. What is successful? Maybe something else, but for now, it's just is. Now this is always a convention. Let's say you want to check is student. That means you want to check whether this variable or whatever variable we're going to use is going to check something if it's a student or not, or is valid. You are going to check whether it's valid or not. And then now I'm going to get back to is success, the one that I started with. So is success. Now, if you combine this with an if statement, then the complete question now is ready. So if is success, in other words, you are asking yourself a question. If XYZ, whatever it is you're checking, right, is successful, then only then do something. Then do this. You get what I mean? So this is how the if statement works. You're checking a condition. The variable right now, we call it if success. Oh wait, it's still if student here, so success, right? So if this is still, if it's successful, then the condition will be true, is that right? And if this is true, then this will become true, then this code will execute. So print, we're gonna print a statement here that says, oh wait, this is still Python, sorry. We are still in C++, so we're gonna use this guy right here. So I'm gonna say cout. I'm going to say here success, yeah, and that's it. I'm going to remove all that other stuff here. Okay, so basically, if it's successful, we're going to see success. Otherwise, it's not going to be successful, right? Now, how do you know that? What happened here? Oh, I closed the thing. Oh no, wait, undo, whatever. Oh, I closed the file. Sorry, guys. Let's go to this. Yeah, this is my program. Just now I clicked a command that closes the file. I forgot. I hope I saved my work. Yes, I saved it. So let's read the code and follow the logic. Remember I told you before you have to follow the logic, right? So I start here. Okay, this is an integer. Okay, this is a float, or this is okay. This is a Boolean. Right now it's set to true. Okay, this is a string. This is a variable, and a character. All right, so let's come here now. This checks a condition. This condition right here checks this current condition. The condition is set to true. So right now this is true. I'm following the logic of the code. And because this is true, this is going to execute. So therefore, I should see this guy in the code, in the results. Then after the if statement is completed, right, then all of these bunch of lines here, they're going to run anyway. So we're going to see those guys as well. So a good habit for any programmer when you're writing, especially if you are a beginner, right, that you try to predict the behavior of your program before you run it. It's very, very important, because if you can successfully predict what your program is going to do before you do it, or before you see the output, then you are doing two things at once, or you're learning two things at once. First of all, actually three things at once. You're writing very good code that you easily can read. Number one. Number two, you can follow the logic of your code. Okay, this is set to true. then if this is used here, and then because this is true, then this will execute. This is called following the logic. And finally, you are able to understand or work like a computer or think like a computer, like a compiler. Okay, this command right here is done, or this block of code has finished. Now there's a bunch of lines, there is no conditions associated, so they're going to run anyway. So what I expect to see when I run this program is one line and then followed by 1, 2, 3, 4, about 5 lines. I should expect to see 5 lines when I run this program. So you think about it, try to predict what you're going to see, and then test it. And then if you see your program run exactly how you planned it, then you are good to go, because that will help you to build confidence in yourself that you are writing proper code. If you are able to read and predict your behavior of your program before you run it, then congratulations, you are really able to write code successfully. But if your program is doing something else other than whatever you predicted, then obviously you need some work to be done. So let's take a look. I predicted this will run, and then these 4 lines will run, so we should see 5 lines. Let's go. Success, and then wait a minute, these are all a bunch of lines together. So what's going on here? Oh, I think I know what's going on here. The program ran successfully, but unfortunately, just now I removed this from the beginning of each line. And as a result, because I removed this new line, all of these texts that you see here, they will add it to the previous print statement. So you can look at it, take a look. First of all, my age is 44 years old, and straight away comes the next line, which is the temperature is, and then after that comes my blood time, because I did not put a new line in at the end. So if you want to make sure that every statement is starting in a new line, then you should do this. So do I have to always put this n at the beginning of the line like that? No, if you want, you can just do it by itself in the end. Like you can come here actually and cut this guy and then come here if you want and do it like this, but don't forget to put it inside a double quote. Okay, and then that will actually tell the compiler that at the end of the first line, make sure you put a double line, or and start from a new line. Right here, there's nothing here, so I'm just going to do this. Okay. What's going on here is that, again, just for clarity, right? I'm putting these new lines at the end of the line rather than the beginning of the line. So this way, my code will be better organized and easier to read. If you want an extra space in the beginning for clarity, that's fine. If you want to start a brand new line from scratch, just like I did here, so that's fine. If you want to put it in its own cout, okay, so this is also doable, and you don't need it now here because you've already done it in the previous line, and then that will be good to go. So let's clean up a little bit here. Once again, you should be able to read this correctly. So don't forget, compile success, build success, and then execute success. And now every line is started in a new line. Why this guy in the beginning is not indented? Because I did not add an extra space here. So now, once again, compile and build, and then execute, and now it runs very nicely. And success. Once again, between success and my age, the lines are not breaking. Oh, I forgot to add a new line at the end of the first line, so it's going to come here. And you know what? This is a good exercise of following your logic. What I want is I want every one of these lines to start in a brand new line. But when you actually print it out like this, it doesn't. You can see that success, the first success, right? Okay, start in what happened to it? Okay, the success is right here, but then it does not start with a new line. So something is wrong here. So this is where you should follow the logic of your code. You should read your code again and see why there is no break line here. So you read success, okay, and then here my age. There's no break between them. So you might want to actually add a break the same way you're adding here. So I'm going to come here, copy, and then put it here. So this way, basically, right, now, after the success, we will start a new line. Then we have my age, then new line, then my temperature, new until the end. Okay. Again, compile, wait, build, wait, and then success, and then now everything is perfect the way we want it. So hopefully by now you guys have understood a bunch of terminologies that I discussed before, like following the logic, able to read your code, ability to write code that is readable. These are all skills that you must develop from day one if you want to be a good programmer. So I could have written anything else here, actually. George. I could have called my variable George, actually, if I wanted to. And that will still work, actually. I have to change it here also. George. Yeah, it does work, actually. And my program will run. Believe it or not, it runs. Of course, using George as a variable name is not a good idea. Okay, that's because I might remember what George is, but believe me, like tomorrow morning or maybe 3 hours from now, I will not remember everything. But let's say I come back next year or a few months down the road and I read this code again, and I read the variable name, it says is success, I will remember a few things. First of all, this is the flag because I put is success in the beginning. Is a question. Is this success? Something like that, right? And then I will know that this is referring to the condition or a status of success, whether it's true or not. So hopefully now you understand how to write code properly, how to organize your code properly, and how to make sure that you're able to read it. It's 5:20. You have about a few minutes to go. Let's talk about something else. I think we have time to talk about arrays. And then next session or next week, we will talk about operations. Where did that thing go? Yeah, okay. So these are the variables, and we talked about variable declarations, and here's how you declare different type of variables. This is supposed to be blue here. Then again, how you work with variables. We will deal with user input next week or next session, but for now, later on. We can probably do that now, actually. Yeah, why not? We will do that now. Rather than working with arrays, we'll work with user input. So we talked about another source of variables for a program is using user input, meaning you allow the user, when they run your program, to input values. And then, just like we have cout, which is the output, we also have cin, which is essentially a C library, by the way, not a C++, a C library. And then we're going to use it to declare, to capture a variable. So how are you going to do that? Well, simple. So we're just going to simply come to our program. You know what? I'm going to copy this whole thing. Control X. And then run the mouse here and double click anywhere here. It will open a new file and then Control V. I don't want to delete the code. I just want to put it away for a while. So temporarily I moved it here. Okay. So now we have the program and we have this structure right here. If you notice that I'm writing all my code inside this main function. This is something to do with C++ or C actually, that everything has to do inside the main function. Okay, what's next? So let's now ask the user to declare you know what? I forgot how to do that. I know it's in the slides and everything. I'm just gonna forget how to do that. So I'm gonna come here now again to my, not CSS, sorry, C++. So my C++, and I'm gonna look for user input. I think it's somewhere down here. If you cannot find it, just Control F to find and then type user input. And you can see it's right here. So once again, how to do this? If you are looking for something on the page, just Control on your keyboard, yeah, Control and the letter F, and that will open up this small banner here, and you type whatever you're looking for. So user input, and then I found it already, so I can click on it, and now I can know how to use a user. How to use a user input. So this is an example we're going to copy, basically. Actually, this one is exactly in the slides, right here. Or a different version of it. Yeah, it's right here. This is the one. So how are you going to actually capture user input? So first of all, what you're going to do is that you're going to actually initiate a variable. So let me say that one more time. You see, earlier when we worked with variables, we had to declare a variable. Declare a variable means what? Declare a variable is declare a variable. You declare a variable, you have to define everything about the variable, the type, the name, and the value. All of these things together. When you define them directly like we did here, so this is called declaration. Okay, but sometimes you want to declare a value, you want to have a variable, but you're not sure of the value, or you don't know the value. Maybe it's something that's going to come later. Of course, we could always give it an initial value like 0 or something like that, and then the value will change. But if you want, C++ allows you to initiate a value. To initiate a variable means what? We're basically going to come here. Initiate a value is similar to declare a variable. So initiate a variable. All you need is just the type and the name, and that's it. You don't need a value. So I will declare, or I will define integer, and then your age. And I don't know the value yet, so I'm just going to put semicolon right there, and we're good to go. That's it, nothing else. So if you're thinking, so we have a variable, but this variable has nothing inside it. That's fine. So you know what? Let's just take it out. It's successful. Okay, build successfully. Now let's just try to print out the value, right? So C out, copy, Control C, and I'm going to come here and C out your age. Try to print this on, and once again, before we run this, you want to ask yourself this question: what's going to happen if I run this program now? I initiated a value, it's an integer, and I did not give it any value, but then I'm trying to see out the value. So what's gonna happen? Try to think about it for a minute, and then we'll see what happens. So compile. What is that thing doing? Compile, build, and run. Nothing. Because it was declared as an integer, actually the value is not 0. It's actually something called, it's not a blank, I forgot what's the actual term, but it's something that is not associated, it's not given a memory space. So we're just going to ignore it for a second, that it does not exist. So although the variable is there, it has a memory associated with it, it's an empty box that does not contain anything yet. So we need to actually give it a value. We need to assign a value to it. So okay, that's what we did here. We initiated the value, and then we're going to ask a user to give us a value, and then we're going to take whatever user, so C out, please type your age, and don't lie, and don't. Okay. So this is now a string, and notice how the color changed when I added the other semicolon. You get what I mean? So that's the compiler talking to me behind the scenes, telling me, okay, you're good to go now. So okay, now that I told the user to type in something, I need to capture that information. So what I'm going to do is cin now, and then the arrows are different. These are actually arrows. You are sending it out, right? But now you're going to, whatever captured value that the user inputted, we're going to take it, and then we're going to assign it to your age. So now what's going to happen is that, I hope you guys paid attention. So first of all, we initiated a value, but no number, a variable, but we did not give it any value. Then we asked the user to give us the value, and then whatever the user typed, we captured it using the cin library, and then we assign it to this value right here. Okay, fantastic. So now what? Now we need to print it out. We need to reprint whatever the user typed. So it's going to come here and type C out. Thank you. Your age is, and then we're going to come here and then your age. Yeah. By the way, you notice that as I type the variable name, it already comes out here. This is actually a great help. This is called line completion. If you don't want to type the rest of the thing, just type tab. Just or click on it if you want with the mouse, or type tab on your keyboard, the tab button. It will, the rest of the variable name will come out. So this is one of those useful and helpful things for your code. So once again, let's follow the logic of the program. I declared a bunch of variables here. We're going to ignore them because we don't use them again here. Now I initiated the variable. Okay, thank you. Now I'm asking the user to give me a variable. Okay, good. Now I'm capturing that variable, the value from the user. Okay, good. And then I'm basically printing out again the value. This is called confirmation, or feedback, to tell the user, okay, I successfully captured whatever input you have given me. Once again, it's a great idea to try to read the logic and hopefully try to understand what's going on with your code before you run it. Okay, all right. Oh, error. I may have forgotten a semicolon somewhere. C out. Yeah, I've forgotten a semicolon. Notice one thing here, yeah. Yeah, good job, Nick Mohammed. You actually, yes, I have forgotten to do it, and that's why I got the error. So, but before I do that, notice one thing though. When this was happening, notice how C++ pointed you to this line, right? Not this line, yeah? So although the message down there is telling you line 30, yeah, we are on line 30, expected semicolon before C out. Before C out, okay? See right here, there was supposed to be, so the semicolon was missing actually not on line 30, but missing on line 28. You get what I mean? So that's why sometimes the compiler does not point directly to the actual line source of the problem, but to the line after it. So sometimes if you see an error and there's a problem on a specific line, you might want to think about it this way. Okay, maybe this is okay, but maybe the problem is happening on the line before it, or maybe a few lines before it, okay? So once again, let's try this now with the semicolon. I write programs in Python a lot. So it's a habit that I stopped writing semicolons. So this will affect me when I write C++. So again, let's compile. Now we're successful. Build, successful, and execute. Please type your message. Don't lie. Oh yeah. Okay. My age is 44, 45, 44. And thank you. Your age is 44. It's nice and all, but I don't like how, I don't like how the 44 is right there at the letter. You see, it's right there. I don't want it to be that way. What I want to happen is that when the letter, when it says don't lie, I want the 44 to be on the next line. You know what I mean? So where do we go and do this? So once again, think about this. I want right now when I run this program, the 44 will come right here. But I really don't want it to happen this way. I want it to happen on the next line. So any suggestions? How do I make this happen on the next line? Is there something that we can use to make my age or make this line happen in the next line? Very good. So this is a trick we already did. Thanks again, Adam. So this is something we did earlier. So there is no need or nothing wrong with doing it again. Now, of course, I could do this. Yeah, I could do this. Or if you want, you can just come here in the end and type it directly. You know what I mean? Not a problem. I just feel happier to put it this way. I mean, just convenience. I mean, I just like it this way. Okay, after that, the 44 will come out, and then this one will come here. Then we're good to go. So let's try. Don't forget, compile and build and execute. Type your age, don't lie. Notice that the blinking line is now on a new line like we wanted it. Okay, good to go. 44 or 45. And then thank you, your age is 44. We're good to go. Our program is running as the way we want it. Okay? Now, let's say, right, that I don't want to print thank you, your age all the time. I want to actually have a little bit of fun. So I want to come here and type integer or declare new integer to old. No. Yeah, age limit. Age limit, we're going to set the value. This is going to hurt me, but I'm just going to do it anyway. So let's call this 25. No, let's not call it 25. Let's just call it 20. This will hurt you as well. Okay, so now we want to do a little bit of fun, right? So what do we want right now? Here's an algorithm for you. Okay, I'm going to write it now in plain English. Okay, the algorithm is simple. If the age is under 20, okay, print a message that says congratulations. No, without this. Congratulations, you are a teenager. Okay. If above 20, then the message should say you are too old. Okay. That's it. That's the algorithm. Go ahead and try to implement this. It's a simple if statement. We have done an if statement a while ago, and you can actually see it here. You must have it already on your code. So we have an if statement. We have a condition. So the condition is that we have defined an age limit equal to 20. In fact, I already done half of the work already. So based on the value that the user inputs, then the message should be different now. Okay, so I'll give you guys a moment. Let's say 2 minutes to do this. Actually, less than that is enough. But go ahead and do it. Try to write this code on your own. I'm gonna unshare my screen, and then I'm gonna give you a couple of minutes while I do it myself. So I'm gonna come back. Right now it's 5:37. I'm gonna come back at 5:39, and then we're gonna see the code and compare notes. So you guys go ahead. If you want me to, I'm gonna copy these instructions right here into the chat area, and then go ahead and try to implement this simple algorithm. That if the age group, if the age is under 20, you're a teenager. If not, then you are too old. Go ahead and do it. I'm going to unshare my screen, and I'm going to do it myself, and then we should compare notes. All right. So let's see what you got. Okay, if you are able to do this, and maybe not exactly the way I did it, but if you were able to do something similar, then you can consider yourself like sort of done. So what I did was I just put an if statement, and it says basically I first ask the user to input the username, which is unchanged from what we did before. So please type your age, don't lie. This is untouched. It's exactly the way it was before, and then I take the value and I assign it to your age. And then I check the value directly. If the value was less than or equal to 20, okay, if that's the case, then you are, and then I put the value of the age, and then congratulations, you're a teenager. If you did not do this part right here, that's fine. If let's say your if statement was like this, it's okay. So like the original requirement, right? I just wanted to add more information to the statement, but it's fine. If you just wrote this, it's also okay. Even without this line, also okay. So let's say if this was your answer, then congratulations. If not, then don't worry, because we haven't done these yet, or even the if statement, but I just want to, give you the feel of it. So again, if your age is less than or equal to 20, then congratulations, you are a teenager. If you are 20 or older, then you are too old. Okay, let's get that test run. So compile, build, and run. So type your age, let's say 17 or 15. Congratulations, you're a teenager. Well, it works. Try again. So let's say 2034. You are too old. Okay, so basically that's how, now what I wrote earlier was I also sort of provide an output to the user. So what it means is I also print out the value of the user the way we did it before, basically. So compile, build, and run. So if I type, say, 17, so you are 17, congratulations, you are a teenager. Okay, so that's essentially this part of the statement is the confirmation, and this is the statement or the result. And let's do this again, and then say I'm 233 years old, you are 33. Maybe I should have added years old after that, but it's fine, and you are too old. Okay. So these are just, if you didn't able to do this, or if you got lost in the if statement, it's fine. Don't have to worry about it, but I hope you did something what I did, like sort of you Googled it and check it out online, and then copy the code from the same way I did it. So now basically we have worked with variables that we declared ourselves. We have declared with variables that we ask the user to input, and then we've seen some operations like this guy right here. In the next class, we will work extensively on operations. Apart from capturing or defining the variable and then printing it out, we have to do a bunch of operations to the variables. Remember, programming is all about manipulation. Remember that? So manipulating of what? Manipulating of data. So you have to do assignment. We actually already did some assignment already. We have to do arithmetics. We have to do comparison, logical, and mathematics, advanced mathematics. So that stuff, we will do all of that in our next session. Yeah, in our next session also, we will begin by talking about arrays. I spent a lot of time talking about setup and all that stuff, so don't worry about it. Also, If my lecture videos or the live lectures do not cover everything in the slides, also do not worry, because I'm going to make a separate video where when the slides are completed, I'm going to make a separate video just when I go through all of these slides one by one. So those videos will be longer than 3 hours, I think. So you can go through those, or even going to be in parts, maybe one part on variable, one part on arrays and stuff like that. So there will be more details. The recorded videos that you might have already noticed is exactly like the lecture videos. It's just that the only difference is that you cannot ask live questions. If you found something in the video that is quite confusing and you don't know what's going on, you can ask me in a group, or you can type it in the comment area on YouTube, or you can just chat in the Telegram group. So what is left? So next week when we come back to this, or in the next session, we will talk about arrays. We're running out of time, but I think, we're just going to describe it clearly. Describe slightly what an array is, but then we're going to do some testing with it next week. So we have already declared variables, and we have seen how to work with variables so far. And variables could become in different types. You could also declare a variable. You could initiate a variable. You could ask a user to give you the value for the variable. Yeah, there's a lot of ways you can work with a variable. Now, of course, in the next class, we will also see how you can update the variable, like how you can manipulate the value of the variable. Now, and now a different thing of variable is that sometimes variables could be not an individual variable. Sometimes it could be a collection of variables. Like, for example, you are right now, when I say a class, I don't mean the physical building. I mean you guys, the group of students. So I treat you as a single group called, essentially called my class. And inside that class, it's a collection of students. Is that right? And each one of the students essentially is defined by a number of parameters. Each student has a student ID number, has certain other definitions like a registration key, and also username, name, and email, and a bunch of other parameters. Of course, there are other things that define you as a person, like personality, looks, whatever, culture, background, language. These are not related to you as a student. We are talking about you, the student, not you, the person. Similarly speaking, here in collections in C++ or in Python for that matter, collections are essentially variables that are grouped together and then treated as a single unit. I already mentioned a class as an example of that. Okay, there are many different types of collections, each with its own properties and features. In C++, we will focus on these two types of collection. This one you might have heard about before. It's called the array. An array is a collection of variables that they are all of the same type. So if I want to declare an integer array, that means every item in that group is an integer. If I want to create an array of characters, then every item is a single character. If I want to create an array of booleans, then every item is a boolean, and so on. Similarly, that's what I meant by same type. And the number thing about it is that it's fixed size. What does that mean? See, right here, when I declare a variable, this is right here is a definition of an array. We declare the type. This is basically a string array. And we also define the size of the array. This array contains 4 items. So when you declare this array, you are telling the compiler, hey, compiler, here's the 2 information that you need about this array called cars. So later on, when I mention cars in the program, the compiler will know 2 pieces of information about it. First of all, it's an array of strings. And there are 4 different strings in it. That's right there. So that's the first one, second one, and the third one, and here's the 4th one. Is that clear? Now, another thing to remember that right here, we simply initiated the array, meaning we initiated the array, but we did not declare its variable, the same way we did it with variables. The way we declare a variable and initiate a variable is very, very similar to the way you declare an array and initiate an array. Similar, here we initiate an array by, first of all, defining the type and the name. And because it's an array, you have to also declare the size. So right here, it tells you that this is a list of, or an array that contains 4 items, okay? And these 4 items are expected to be strings. All right, thank you. Here's another way of declaring the same variable, but this time we're not just initiating the variable, we are also essentially defining the items inside the array. So that's how you do it. So you declare, because you said 4, so you can actually did all of these 4 items. If you decided to add one more here, but you left this 4 unchanged, then this is going to be a problem. In fact, let's do that in the program. So let's go to our program right here, and let's just do this, yeah, int nums, and then I'm going to put 5, you know what, 4. So what does this tell you? What do you learn from this? First of all, it's an array. How do I know it's an array? Because of this right here. It's a bracket with the number inside. That's an array. Okay, that's an array. That is, the name of the array is nums. Okay, well, what's the type of the items inside this array? Well, they're all going to be integers. So if I just do this, this is just an initiation. So if I want to declare it or declare the variable correctly, then I have to really decide or really put the items inside. So since I need 4 integers, here we go. So 4, 5, 23, and then 9 or 7. So right there and then, that is essentially an array. So let's say I want to see out. No, I'm not sure if this is going to work, but I'm going to give it a try. Now, I don't want all of this to run, so you can comment out if you don't want to remove. Got the keyword here, comment E. Yes, if you want to comment in one block, you don't want to comment line by line, just select the whole group and then Control E. Control E, this will happen. If you want to undo this, Control E again. And then this will, if you want to comment a block out of your code, let's say I don't want to bother with this right now. I want my compiler to ignore all of this, so just select it and then Control E. It's a lot better than going line by line and stuff like that. But then after that, if you want to undo this, just select the same block of code and then Control E again, and that will remove the code. And notice those other comments that we put earlier ourselves manually, these remain untouched. Unless you Control E again, then they will remove them. So now let's just do this. Okay, and then now this whole thing is going to be considered as a comment. And then comments are essentially, as the name implies, just a comment that you write to describe what's going on. And the compiler will ignore the comments. It will not process these comments. The comments are meant for you only to learn to describe your code. Sometimes we comment out something. This is an expression in programming. You might want to learn it. So comment out something or a block of code, right? When you comment out something means you simply do what I just did here. I want the compiler to ignore this part of my code. I don't want to compile it. I just want to ignore it for now. So I will comment it out. Okay, so later on when I'm done with it, I want to uncomment it out or just say include it back again. Just do this. So now we have included. So I want to comment out. Okay, let's comment out. So let's go ahead. And now the compiler will ignore all of this. This is a great tool for debugging later on. So right now I want my compiler to simply run this line of code and ignore everything else. So let's do this. Error. Oh yes, cout does not work on an array like that. In Python this will work, but in cout does not work on that. And let's just try this, str. No, this is not Python again. Forgot the command to string, I think. Ish. Actually forgot how to print out an array. I have to go through the loop and all this stuff, but you know what? This is shortcut. Let's figure out a shortcut from C++. Print out, or no, cout an array. Array in C++. You see, there is nothing wrong with doing this. There's nothing wrong with checking out hints and examples. Cout a whole array. This is exactly what I was trying to do, right? So let's see if that actually exists. So I want to see out. So the shortest answer was to do a bunch of things like that. I don't like this. I'm just going to go in and down here and see what this guy's doing. No, this is also considered doing. This is a loop. I don't want to go through loops. This is also a loop. Yeah, there are other solutions, but this might involve C++ 17. This is 11. Yeah, this is 11. Oh wait, this is the question, the guy who asked the question, so I'm not sure if this works. So no, I don't like to work with, this might work and all, but this again, you still need a loop. I guess there's no other choice but to see out individually using the loop. Okay, but let's not go through that. So the way that it works is that you will have to loop one by one, and then inside the loop you have to print item by item. So forget that for now. You know what? Let's not see out the whole thing. So see out. Let's not see out the whole arrays. Just see out one item of the array. So I want to print out the first item. So how do I call this? So the way you do that is that you simply use the index. So the way that this works, actually, the way that array works, every item you see in the array has an index. Index means that this is item number 0, and this is item number 1, and this is item number 2, and this is item number 3. Sir, didn't you say they have 4 items? Yes, they are 4, but they only start counting from 0. So this is the first item, but its index is 0. That's how arrays work in C++. So this is the second item, but its index is 1. And this is the third item, and so on. Why they didn't just do this, sir, and then start counting like this? Don't ask me that question. Ask the guy who created C++. But there is actually a logic behind it. They call this zero counting, or zero indexing, or 1 indexing. But I think in Python, arrays goes like that, starting from 1. But in C++, arrays goes from 0. Okay, so we're almost 6 o'clock, so we are finishing now. So I'm just gonna type the first item, and we're gonna close. So semicolon here, and it's still not gonna work because it's an integer, not a string. Let's try this. The number is, and do this. See out. Oh wait, see out as a print out, like the way Python works. Apologies. So right here, this now is going to work. Yep. So again, when you work with multiple languages, you can. Oh yeah, this has to be double. Okay, so now this works, and run. So now this is the first item. The number is, the first item was here. So you can say the first item is, and then yeah, so right here is the first item. So run, compile, build, run again, and then the first item is 4. Okay, so already 6 o'clock, we're running out of time, but then I hope by now you guys can see how we had a glimpse of arrays. We're going to continue to work on arrays in our next session next week, but for now, time is running out, and then we continue with arrays, and then we're going to work more with operations. We reached at this point where we are at C++ operators. Now, in operators, there are actually several types of operations. So, so let's get back to our code. So last time what we did was integer, let's say temperature equal to, not integer, let's call it float. So float temperature is equal to 44 degrees. If that's the case, then we will all be dead. But anyway, so now also see out the value. Then we say, you know what, the temperature is, and then temperature. Is that right? And that's it. So that will be, you know what, I'm also going to add the new line as well. Okay, so that's basically it. So now we try to compile, build, and run, and here we go. That's the statement. Now, this is what we did last week. So we just declare a variable and then we display it. Now, in operations, there is actually a lot of the stuff you can actually do with variables before you can display it. You can do the first type of operator, or the operators, is the arithmetic operators. You can do, you know, plus, minus, multiplication, division, modulus, and then increment 1 and decrement 1, and these are all we can do actually here. And these are examples of how you can actually update the values. I'm not. These are sorry, these are the arithmetic operators, but then these are the assignment operators. So example of arithmetics, we can always just say, you know what, you can say no, let's just say temp is equal to temp minus 5. That's it. So basically, this is an arithmetic operation. We are just subtracting. And now when we update this number, and then we basically hit compile, build, and run again, you will see that the temperature now has changed from 44 to 39, which is 44 minus 5. And actually, you can do that again. You can actually change this right here that I'm changing right now. This guy is called the operator, and this is an arithmetic operator. And of course, you can go ahead to these slides and you can try and experiment with all of these other operators as well. What else is there? And then after that, we have the assignment operator. The assignment operator is the equal sign that we've already used. So again, this right here is what is called an assignment. That's why somebody might be, if those who are not familiar with programming or they were doing programming for the first time, when they see this line right here, they might get confused. How is temperature is equal to temperature plus 5? That does not make any sense using algebra. Is that right? But then, by the way, what is going on here? Can somebody explain to me this line here? If you think about algebra, this does not make any sense because you know what? Temperature is equal to temperature. But then right here, we are not in algebra. We are actually writing a program. So what's going on here? This one right here, we are familiar with. This is, temperature is equal to temperature. But then here we have temperature is equal to temperature plus 5. So how is this valid? Can somebody explain this?
Sir?
Go ahead.
As for this case, do you need to differentiate between temperature and temperature? So you need two different temperature 1 and temperature 2?
No. This is still valid 100%. In fact, I can run the code right now. In fact, we already run the code and showed you right now. So compare, build, success, and yeah, it's running. So this variable is exactly this variable. Yet you can see this line right now that looks like that looks weird for a minute. It looks like temperature, and then we have plus 5. So my question right now is that this line right here is valid 100%, yet it does not make any sense from the point of view of algebra. So can somebody explain to me what's going on here?
The new temp is saved as 10 plus 5.
Yes, I'm gonna actually try to explain it better. This equal sign, okay, this is the point that I want to actually explain here. This equal sign that you see right now, it's not a comparison. A comparison means in algebra, when we say A equal to B, we are really comparing between A and B. This right here in algebra, we are saying that A is equal to B. We are making them equal. You know what I mean? So this is a comparison. When we actually do this in algebra, we are actually saying that A is equal to B. But in programming, this single equal sign right here, it does not mean equal to. It actually means assign this value. What does that mean? It means when we come here and say a float temperature equal 44, what does that mean? You are declaring a variable called temperature, and then you take this value and you are assigning this value to this variable. That's what you are doing. That might make sense in algebra, but then what's going on here is that this is how it's going to happen. We're going to take this variable. We're going to start from here. You take the variable or the value that was already in temperature, and you can see from the previous line it was equal to 44, right? So we take whatever value you have here, we plus 5. So 44 plus 5 is 49. So now the new value, which is 49, is now assigned to this variable, which happens to be the same guy here. So what we are doing, we are updating the value. So what's going on here? Usually when you operate a command, you start from here, from after the equal sign. You start from this variable, take the value. Okay, that's 44 plus 5. Okay, so then you take whatever result is that's going to become 49, and then you take whatever result of that 49 and you assign it to the temperature value. So this way the temperature after this line has been updated to become 49. Let's do that. Let's check it out. Run again. and now 49, as you can see right here. So in programming, in any programming language, by the way, this symbol right here does not mean equal. It means assign. And that's what I mean by assign operator. Assignment operator means is that this guy right here, it simply means set this value to 5. So when this symbol, actually, when you read this in programming, we don't say x is equal to 5. No, we mean take the value 5 and assign it to variable x. That's how you read this line properly. Is that point clear for everyone? If it's clear, thumbs up or something. If it's not clear, just ask your question. So that's why you see this line again here. You see what's going on here is actually this line right here. Once again, that's why this is not an equal sign. This is actually an assignment. So what do you mean? We start with whatever value this was before. Let's say it was 1. We take the value of 1. We add it to 3. OK, so 1 plus 3 is 4. And then whatever result of this addition is now assigned to x. So that's how you can update the value of the variable in any programming language. So this is an assignment. This is the equal assignment. So sometimes before you assign, you can actually write this in a simplified way. Rather than doing x equal to x plus 1, you can just write it like this. So right here, this is x plus plus equal 3. This is a short way of writing this line right here. So whether you write it x equal to x plus 3 or you write it like this, then that's not a problem. It simply means x plus 3. And of course, this is the minus, which equals to this. This is the multiplication, the division. These are all the same thing. So these are all how you can actually do assignment values. This is the modulus, which is another operation in arithmetic operation. This, I think, is something else. I forgot what it is, but then you can check it out. This is the exponential and so on. But then these are our other or are considered assignment. Is there any more assignment? Yeah. There is actually one more, which is plus plus. Yeah, right here. This is another arithmetic operator. It was supposed to be also in this slide, but it's not. Is it? I think it was deleted by mistake. That a plus plus essentially, if let's say I go here and I edit it here. So let's say if I do this, you know what? I'm going to do it here. If I do a plus plus, actually what this means is equal x plus 1. So this is what really mean by x plus plus. So when you see x plus plus, I'm sure you've seen it in other programming before. So whenever you see this line right here, it simply means x equal to x plus 1. Sir, if I write it like this, or if I write it like this, is there any difference? Not at all. No difference in performance whatsoever. Some languages, however, some languages do not support this anymore. They only support this only. I think Python is one of them. They don't have this anymore. For some reason, they removed it, but only available this guy. But it's basically, it means the same thing. And by the way, this also applies, which means -1, decrement. Is that clear? So this is now what I mean by assignment operators. And before that, we meant arithmetic operators, which is very simple operators: plus, minus, multiply, division, modulus, increment, and decrement. Is that clear? And the meaning of it is right here. The easiest operators of all are the arithmetics, because you can immediately understand their meanings. Assignment operators might be a little bit confusing for beginners, but that's exactly what it is. Now comes the comparison. Now upstairs, or earlier, sorry, when we say that in algebra, when we write A is equal to B, we mean comparison in algebra, right? But if you want that effect, if you want to check if A is equal to B, the way you do that is actually by doing this, 2 equal signs. Actually, by the way, if you try to do this, temp plus 1, that is not going to cause an error, but it's going to do something else. For now, let's call this, temp old, right? Let's call it this way. So what's going on here? If you put a double equal sign like this, then the double equal sign exactly means what we understand from algebra. So if you put a double equal sign, then therefore it means comparison. Basically, you're asking a question here. Is this temperature, or is this temp, is it equal to temp old? You're really asking a question. Actually, this is what it means. Is temp equal to temp old. That's really what this line of code is doing. And usually whenever there is a question mark, like what the answer is always yes or no, or true or false. So right now, if the answer is true, if this variable also equal to 44, like here, then this will return true. This line will give us true. But if, let's say, if I come here and do this, temp equal to 5, what do you think is going to happen? Is this an error? Is this going to cause an error? Anyone can answer this. If I leave it like this, is it going to cause an error? Is it going to crash the program? Well, you can always destroy it. And yes, there's an error because this is a warning. A statement has no effect because I'm basically asking. In some languages, this would not cause an error, but it's going to return a false. Basically, this is actually a test, but then over here, you're doing an operation. One reason why there's an error here, because right here, this statement is at comparison. You are basically comparing something, but then right here, there's an operation in between. So that's why this won't work. I'm not sure if this would work or not. Let's try this. No, still the same effect. In Python, this will work actually, but it's not going to cause an error, but it's going to return a false, because temperature can never be equal to temperature equal +1, because obviously they are different now. But then right here, you have an assignment, or you have a value, but then here you have a comparison, so might actually not work. So the point we want to make sure or to discuss right now is essentially that you have a comparison which is double equal. This is not equal. Greater than, less than, greater than or equal, and less than or equal. And finally, after that, you have the logical operators, which is and, or, and not. So this is right here is you're basically saying if x is less than 5 and x is less than 10. Over here, by the way, this should probably be greater than 5. Because if it's less than 5, then it's also less than 10. This will be redundant, but if we do this, no, if we actually do this, and then this will never work. This is, yeah, this can work. Less than 5, but also greater than 5. This will never be true, obviously. This is mutually exclusive. But it doesn't matter really with the condition. But the point here is that to remember that this means and, yeah? So essentially it means that we are checking this condition and this condition. If they are both true, then return true. Over here, we're checking or. You are checking two conditions. If this condition is true and this condition is true, then do this something. And right here is the or means the not means whatever you do inside here, find the opposite of it, or like return false, return basically the opposite of the condition. And then of course one more operator is advanced mathematical stuff like max, minimum, square root, round, log, and absolute, and all of these other lovely mathematical operations which we can use from the math library. So essentially, in order to use math library, you cannot just straight away write it here. Like, let's say if I write, you know what, let's just do it here. So temperature, and then we write ABS temperature. If you try to do this, it won't work. It's going to complain because they don't know what ABS means. Okay, they don't know what ABS means because I did not include the math library. I think it's C math, if I'm not mistaken. Let me try include C math. Ignore this. So include C math. Try again. Yeah, works. So basically, the absolute or ABS is a function of the. Let's say that this was negative. So if this was negative and you try to print out the absolute, it's going to print out positive value. Is that right? You try. And you see a positive value. And let's say if I remove the ABS and try again, you would see a negative 44 right here. All right. But then if I put ABS again, it's going to remove the negative sign and going to print out the positive value. So once again, this is how you use. By the way, for the other operators like assignment and all the other stuff, you don't need a separate library. They're all built in. Only the math library that you need to include. So now you can check out the slides for all of these operators or operations. You don't have to memorize anything. These are all available online anyway. Just Google C++ math library and you will find plenty online for operations. But then these are just examples of how you can do with operations. Any questions?
So can I see the code again?
Yeah. Once again, you just have to include CMath, and this is the command right here.
Like when I type for the absolute temperature, it says compilation failed.
Compilation failed. Did you include the library?
Oh, okay, sorry.
So in order for the math library or the math operation to work, you need to include the CMath library. So make sure you type #include CMath. Go ahead and try it and let me know. Did it work?
Yeah, it works now.
Yeah, fantastic. So basically, in order for you to use the math library, you'll have to include it. But all the other operators, there is no need for that. So let's say, for example, I want to find the power of this number. So PWO, that will return the power. I think the exponential. This is going to give me a very long number. Oh, okay, it complained. Maybe I cannot use power on a negative number. Okay, let's try this. Okay, still complained. No matching function called power. Maybe I did not use. Oh, sorry. Power does not. The command power requires 2 items, not 1 item. Sorry. So let's try something else. Let's try sign. I'm gonna find the sign of this number. So sign 44. So let's do that. So negative 44. So compile. Yes, worked. And then the sign of 44 is this. I think the sign function uses radian. So let's say if this was 90, what is sine 90? I forgot. Yeah. So it's either 0 or 1. I don't remember. But you will see this guy right here, because what is going on is that this function here expecting the angle to be in radian, not in degree. So right now this is degree. You may have to convert it into radian. So temp, or it's not temperature anymore, let's call it angle. So angle, can somebody remind me how to convert to radian? I'm not sure if there's a function for that. I don't actually remember, but it's very easy to convert to radians. Can somebody remind me what's the formula? I think divide by 180 plus something, I forgot. Can somebody real quick tell me multiplied by pi, if I'm not mistaken? It doesn't matter. Well, you know what? I want to check it out myself. So I think I wrote it down in my other code. I think somebody may have written it already in the chat area. No, nobody replied. Okay. So I'm gonna come here and try and say convert to degree to radian. Degree to radian to degree. Yeah, degree to radian. C++. I don't remember actually. Yeah, if there's a command for that. Well, it looks like there's no direct command for that, and you have to write the formula yourself. Yeah, it looks like nothing there. But in fact, we have the second price, which is right here, which is yeah, we have the value, which is pi, m pi divided by 180, and that will be the value. So the formula actually is yeah, I think we have to the formula is 2 pi divided by 360, or pi divided by pi multiplied by the angle divided by 180. Yeah, that's the value. That's the formula, I think. So copy. I think someone replied. Yeah, I think the formula is pi divided by 180. Yeah, you need to multiply it by the angle. So basically what's going on is angle in radian is equal to angle multiplied by m pi divided by 180. Now, if you're wondering what is m pi, is the symbol, you know, the 3.14, sorry. Now, you can write 3.14 if you want, but then the CMath library also includes constants. So you can actually use this command right here, m pi, to find the actual constant. And then we come here and say temperature or angle radian. radian, which is this guy right here. So what's going on is that I'm going to start with a 90, and then I'm going to convert it into radian by simply using this line right here. Oh, wait a minute, semicolon, yeah. And then after that, I'm going to check out the sign. Sine 90, I think it's 0. I don't really remember. So compile, boom, we have a problem. So ang radian was not declared. Oh, wait, sorry, I forgot. I have to use I have to declare the variable type. So don't forget that whenever you declare a new variable, you see earlier I declared ang, but when I now declare a new variable, which is this guy, I always have to remember to declare it's, I want to use double. So double is this guy right here, and this is also double. Why I'm using double, not float? Because the pi has a bazillion decimal points. So I'm going to use the more accurate version, which is the double. But if you left it at float, it will still work. MPI was not declared in this throw. What? CMath. Okay, let's see. Let's try and find it. Maybe I did not include the correct library. So once again, CMath constants pi, C++. I hope by now you guys you are learning how I'm using the internet. You know what I mean? So yeah, it's correct. What's the library I have to include? Define, use math, define. Oh yeah, I have to CMath. I have to add one more line. Okay. So apart from CMath, I also have to include this other line to define those constants. So, okay, no problem. So I'm going to copy. Oh, thank you. So basically, this is the command. This is the CMath that I already included, but it looks like I need to add an additional line just for the constant. So I'm going to copy it. I'm going to come here now and go to my Genie. I'm going to come here and put it there. And that's it. So hopefully now with this, hopefully this works. Success. All right, that's great. So now this constant right here is the actual pi constant. By the way, I forgot to go back to that link again, to that page. If you're wondering what else you can use, you can actually use pi. I think there are also exponentials or other logarithms as well. There are other constants as well you can use. What is the list of the constants? Is it just pi? I think there's more than that. C++ constants. Oh, because I wrote pi here. So I just write mathematical constant. Let's see. Wait, it's the same page. So let's see what else is there. Math constants. Yeah, I think maybe this one would be nice. Yeah, so these are actually a bunch of constants that you can actually use, and they are all defined. And this is another nice example. I can't think of another constant right now other than pi. I'm not sure. I don't remember it. Top of my head, I can't remember. But if you come up with another constant, you might want to let me know. But for now, you know how to use the pi constant, which is right here. All right. So essentially, you'll have to include this line right here. Define. This is essentially, it's not a library. It's called a header. But you don't have to worry about that. Let's call it another library for now. So compile, run, and execute. And the temperature is 1, or you know what, let me change that. Sine 90 is, you know what, no, I have a cool idea. So sine and is, and then we find the sine of the angle. Yeah, that's good. So what I did was I constructed an output. So it's going to be not this sine, sorry, sine. Yeah, this sine. So sine the angle, which is 90, is, and then the actual value of the sine. So let's take a look at what's that going to look like. Compile, build, execute. So sine 90 is 1. Okay, this will for me to remember. So once again, how do you do that? So first of all, we use the library, which is CMath, and we use the constant. In order to use the constant, we use an extra line for it. By the way, if you don't want to use this constant, if you just want to use 3.14 something, also can, not a problem, but your accuracy will drop. Of course, the answer is 90 equal to 1 because I used 90. If I put 0 here, then the angle will be, sine 90 should be equal to 0. Let's take a look. So compile and 0 right there. Now let's pick a random number. Let's just say 44, whatever. You know what? Yeah, let's say 320 like this. Compile. And that's the cosine or the sine of this angle, 330. Let's try something else, 120 or 120 like that. All right. You know what? Let's try 45. Because I already know what the sine of this is thing. I think it's 0.707 should be. Yep, 0.707. Sine or cosine 45 will always equal to 747 because it's halfway between the sine and the 0. If you want to test it, you can actually try it. You can come here and say cosine, and then you can see that the answer is still 7.07. And yep, you can see it's not sine anymore, it's cosine. Okay, so this is how basically you work with operators in general. You have an arithmetic operator, you have an assignment operator, and you have, some people will say that this is also an operator, but ignore that for now. And you also have a mathematical operation like cosine, and you also have a mathematical constant. And you also have another mathematical operation right here. Now, there are actually more operators we never use yet, but that actually will be in relationship to the next topic, which is conditionals. Now, conditionals, you have the if statement, the switch case, and the loops are something else. So the if statement is essentially, sometimes you don't want to run the whole, you know what, it's 4 o'clock, let's take a break. So 4 o'clock, let's go for a break. So before we go for a break, if you have seen everything so far, if everything is clear and you can hear my voice right now, please raise your hand. So let me see a show of hands. If everything is clear, if everything is fine, let me see a show of hands. Sir, I did it without the define and it's still okay. What do you, oh, that means maybe in your installation, sometimes it works, sometimes it doesn't work. It depends on the library, to be honest. Maybe in your case, when you downloaded or when you installed the compiler, the define part was preset already, and behind the scenes. But it doesn't hurt to do. If it worked. If it doesn't work, then now you know how to make it work. So, for example, the guy was saying that it worked for him without even this line. You know what? I'm gonna comment it out and try it again. It's gonna fail for me. So maybe for me it doesn't work for my installation, but in your case it does work. It doesn't matter. It doesn't hurt. Some people, the CMath will already include this guy right here. So for some other people, I don't know why, but maybe this will not be included. But it doesn't hurt. If it works for you without this line, fantastic. If it doesn't work, now you know what to do. You just have to define the constants. And what this line really means, it says use, or basically it creates the definitions of the mathematical constant, including the pi constant. Anyway, if you don't want to do all of that, if let's say you don't want to use this constant right here, if you just want to say 3.14, that will also work. I mean, it still works. Just that your number will be a little bit less accurate after a few more decimals. So if you want more accuracy, maybe you can add more, and not just 3.14, 3.4151 something. I don't remember the rest of it. But if you want to hard code it yourself, if you would like to use a symbol, then you know what to do. Okay. So let's take a small break. Okay, so welcome back, and now let's continue with our coverage for C++ refresher. And this is what we've covered so far. And last time when I was going through these concepts, I was going slow because the videos were not ready, the recorded videos, but now the recorded videos are more than ready. So I'm gonna speed up things a little bit. Secondly, I'm not teaching C++ from scratch. I'm just refreshing. You've already had a separate course called programming, and therefore you're supposed to be already familiar with a lot of the terms and the stuff mentioned here already. So arrays, let's talk about arrays. So essentially for arrays, really, we don't need all of this. So let's just throw away all of that stuff. And when we were declaring variables, if you remember last time when we were declaring variables, the structure of declaring the variable was simply type, name, equal, and then the value. Is that right? That's how we declared a variable last time. Well, when we're declaring an array, it's actually quite similar. similar structure really. So you start with type and name, but then we also have to specify size, and then not one single value, but then rather a set of values. Okay, and then of course don't forget to close the bracket and a semicolon. By the way, can you hear me? Can you see my screen? Forgot to check. It's all good? Guys, can you hear my voice? Can you see the screen?
Yes, sir.
Okay, good. So how do we declare a variable? So I'm going to declare a variable of string cars, and this time I'm going to, you know what, I don't want to write it again, so I'm going to copy paste it. So I'm going to go online and go to W3 schools, and basically I'm going to search for right here. So W3 schools, C++, what is it? Yeah, W3 schools, C++ arrays. And that's it. And it's going to open up the tutorial online for arrays. And I'm going to basically use this to copy the code. I'm too lazy to write it again. So I'm going to copy this. I'm going to come down here, and here we go. So essentially, look at the structure you see there. This is the name of the array, and this is the size, which is number 4. And this is the set, this is the equal sign. And by the way, this is not equal sign. This is the assign, essentially the assign operator. So what's going on here? This is the set of values. You're going to take this whole set and you're going to assign it to this variable called, or this array called cars of size 4. Okay. By the way, you want to try this? Let's go ahead and do this. And I'm just going to try Honda here. So you know what? Let's do that in a minute. So basically, what are we doing here, right? We are simply declaring the value or the set of values, and we're going to assign it to this guy. So after that, if you want to access the value, so let's say cout, we can say, then you can say the first car is, and close the bracket, and see, and then we're going to say, then I want to pick up the first car. So now, the thing about arrays that you must remember is that we don't only have values, but we also have index. So the way that the array is actually organized is through something called the index. So what do you mean by index? You see, every one of these values has actually, every one of these items you see here can be designated or can be defined using two ways. Either through the value, in this case, the first item has a value of Volvo, but it also has an index of 0. And this one has an index of 1, and this has an index of 2, and this one has an index of 3. So in an array now, you see in variables, we only have value, that's it. So you can say right here, string car, just car, 1 car equal to, and then I'm going to say Honda, that's it. So in this case, oops, what happened here? In this case, you only have the item, which is, the value, the variable called car, and then it's straight away associated with a value. That's it. But over here, yeah, this guy right here, copy, and we put it here. So now, in essence, now when it comes to arrays, we have not just the values, but also we have the index. And think of the index as like the number that organizes the position of the item. So this item right here is the first one, but we're going to start counting from 0, not from 1. So the first item is starting from 0. Second item is from this guy right here, and so on. So then if you want to access an item from the array, then you'll have to use the index. So let's say I want to print out this guy right here. So take a look at the index, or you can start counting from the beginning, 0, 1, 2. So the index will be number 2. So we're going to come here and say cars, which is the name of the array, right? And then use the index associated with this value that you're looking for. So this value right here is 0, 1, 2. So therefore it's going to be 2. And that will actually print out not the first car anymore. This will be the 1, 2, 3. Yeah, this is the third car. Okay, so compile, hit run. So the third car is Ford. As you can see, yes, the third car is Ford. Okay, so that's how essentially how you can assign an array and you can access an array. If you want to update the value before you access it, not a problem. You can just come here and say cars item number 2 right here, equal to Honda. Okay, and what's going on here is that essentially we decided, you know what, I want to come to this third value or this value here. I don't like Ford, I'm going to change it to Honda. That's what cars mean. This basically what's going on is that this is the name of the array. Go ahead and access that guy with the index number 2. That's what it means here. So you go there, this is the whole array. Okay, what is index number 2 is right here. Okay, so right now this is the value. The value is Ford. Okay, what do you want to do with it? Well, I want to change the value from whatever it is, which is Ford, into this value. And then I'm going to print out. So you should see now the third car is Honda. That's what you're supposed to see in the end. Run it, and boom, now we see Honda. We're good to go. So these are now arrays. Now let's just play a little bit with these guys. Let's say I decided to set the size equal to 4, but actually I put 5 here. What is going to happen? Do you think this will work? Once again, like I said before, try to guess before you run it. I'm guessing we're going to have a problem because I'm already setting the size to 4 items, but I'm adding 5 items. So 1, 2, 3, 4, 5 items, and this guy will have a 4 index, but I'm only declaring 4 items. So give it a try and play. You see, if you read the comment down there, it says too many initializers. In other words, you have set 4 positions, but you gave it 5 items. That's too many. That's what the error code is saying. That's what I said before. The error code sometimes really explains the situations, and you just have to read it. And now we're good to go. And another thing, let's say I put here integer. See, I'm putting an array of strings inside here, but then this guy right here is just an integer. Do you think it's going to work? No, of course, it's not going to work because invalid conversion from constant, a bunch of other stuff going on. What's really going on is that you are expecting a string, but then these are actually, you define an integer, but then you put inside a bunch of strings. Obviously, that won't work. So that's why you need to put a string here. Okay, so that's actually enough for any questions about arrays before we move on to the next item. Okay, so I'll take this line and I'll put it here. So now then we have worked with variables, we have worked with arrays, and we have talked about user input, and we talked about operations. Next, we talk about conditionals. And the next conditional is the if statement. And you will see when we use conditionals that we're going to use some of the logical operators here. So, you know what, let's come here and say, you know what, if this is the if statement, you know what, I forgot how to write an if statement in C. So I'm going to once again go here, go online and write if statement C++. Just for fun, I'm going to add W3 schools. If you don't want to add W3 schools, fine, but then just so we can if else statement or if conditions and if statements in W3 schools. And here we go. So how do you write an if statement? It's really simple. This is the structure of it. So let's go ahead and copy it. It even comes along with a comment, so that's actually cool. So after I declared my variable, I want to put a condition here. So what's the condition? So this is how the if statement works. If a certain condition, if this condition is true, then in this case, do something. Otherwise, this whole block will be ignored. So let's do something. So let's just say, you know what? Let's just put here and say something simple. I don't want to complicate the program. So int temperature equal to 37 or 34. It is a little bit cold, so I'm just going to say 29. Okay, so and then hash here. And then what I'm going to do right now, I'm going to actually check. Say if temperature is, if temperature is greater than 30, if it's greater than 30, then what do you do? In this case, simply, then we do this code. That's actually going to say, I'm going to take up here, and let's just remove this for a minute. I'm going to say it's too hot. if the temperature is about, those, by the way, if you're an Arab guy from Saudi Arabia right now, and you're looking at 30 and you say this is too hot and you're laughing already, I understand. Because 30 in Saudi Arabia or in the Arab world, or in that part of the Arab world, is considered cold, not cold, considered nice weather. The temperature could get up to 50 at some point in Saudi Arabia or in Kuwait or in the Gulf in general. 50 or 45 in the shadow, not even in the sun. But anyway, in this part of the world or in other parts of the world, 30 could be very hot. And by the way, in Europe, if they ever get 30, it will become an emergency for them. They could actually get drought. But anyway, then after this, well, what happens here is that if the temperature is more than 30, then print it's too hot. Otherwise, obviously it's not so hot, so I'm going to say it's okay, or yeah, it's okay. So before I hit run, I want you once again to think about the program, what you see here. Then obviously we're not going to use any of this. So I'm going to control exit for a while and then be here. So basically I'm just going to focus our program only on this guy right here. So save. So now the temperature, I already set it to 29. So obviously you know that this will not run, all right? So no, let's not do that. Let's just think about this for a minute. So what I want you to do is that before I hit run, or before you hit run, because I hope you are doing it with me right now, I want you to try to imagine what is going to happen. Okay, what is actually going to happen? What is going to be the output? Let's put a pen here in the end for a new line. And I'm going to do the same thing also down there. So right here, yeah. What's going to happen is, what do you want if it's, what we really want actually is that if it's too hot, you print this one out. If it's not too hot, you print this one out. But then that's what we want. So let's see what's going to happen now. Okay, successful. Okay, boom. It's okay. So basically, obviously, since we already defined the temperature to be already 29, so obviously it's less than 30. So this part of the code is not going to execute, and that's why we see it's okay. Okay, cool. So now let's change the temperature. Let's say we have a sensor and the sensor value gave us a number of 35. So now the temperature is greater than 30. Okay. All right. So now I want you to imagine, think about it for a minute before I hit execute, and try to imagine what is going to happen. I mean it. Think about it for a minute. So before I hit run right now, I want you to imagine what is going to happen. You might be thinking, oh, it's going to be greater than temperature, so something's going to happen. So think about it. Okay. Let's go. Boom. If you predicted this output, that both of these statements is going to come out, then congratulations, you can think logically with the program or with the compiler. Now, if you thought that you're going to see only it's too hot, then you're not thinking like a computer. So let's see what really happened here. That's what I meant earlier. You have to follow the logic of the program. So what is the logic of the program? Okay, I define the variable call and temperature is now equal to 35. Then I come here now and I test it. Okay, now if the temperature is greater than 30, well, 35 is greater than 30, so this will execute. Okay, so this will execute. We're going to see the first print statement, which is it's too hot. Okay, that finished. This block of code finished. Then after that, what comes? Then we have another C code, C out. Wait, another C out. And this C out will print no matter what, because this C out right here, the second one, has nothing to do with the F statement. In fact, even if I do this, this still is going to print out. And this is not the behavior that we want. What we want is that we want this statement if it's too hot, and only this statement if it's okay. We don't want them both to appear. You know what I mean? So that's how you can actually solve this problem. So there are two ways to solving this problem. You can always just do else if, and then do another test. Okay, you can actually copy this whole thing and put it here, but instead of less than or equal, you can just put less than or equal 30, and then you can take this guy out and then just put it here. Okay, so right now, this is now the situation. What's going on is that we have an F statement, and this is gonna now, we have two conditions. The first condition, if it's greater than 30, it's going to print this statement. Now, if otherwise, it's going to check this statement, which is actually the opposite of this guy right here. Okay, so let's do this. Let's give it a try. So compile works, and now it's too hot. Only it's too hot is going to present because the other one failed. Okay, I want to see only this guy, so I reduce the temperature. So let's reduce the temperature to 29, and let's try again. So let's close this. So let's try again. So compile, hit, and then you will see that it's okay. Still, 29 is less than 30, so this will not execute. It will fail. So you're going to see only it's okay. All right. Now, before I go any further, there is a way to improve this code. Does anybody know how to improve this code and make it do the same job, but you can simplify it a little bit? Can somebody tell me how can I improve this code to make it a little bit easier and a little bit more efficient? Anyone?
Just put else instead of else if.
Correct, but why?
If the temperature is more than 30, if I put else, everything above 30 will be false. So below 30,
it's all right. I'll accept it. Basically, what he was trying to say, what is correct, by the way, is that you see, if you think about the possibilities, yeah, this is one possibility, greater than 30. What's the other possibility? Less than or equal to 30. Is there anything else? Is there anything else? Nothing. There is no other possibility other than this one. So that's why it's a good idea to just simply drop all of this, because if it's not greater than 30, it's definitely less than or equal. There is no other way. So that's why you only use else if there is nothing else. That's really what the else means. So let's try this again, and successfully, and then boom. And now we can see that it's okay. Now, when do we use else if? Just now, the way that I did it here. The way you use else if there is a third possibility, something else, like some third possibility. In this case, we can just simply say this, right? So this is one condition, that it could be greater than, it could be less than, but there is still one more possibility. And that's what other possibility, what if it's exactly equal to 30? And that is when you actually put the else. So when do you use else if is that if it's just one other situation. Some people can organize these things by putting else here and then the F in the second line like this, not a problem, and then you can put the bracket here. So the way that this works actually is that right here. And the way that this works is that when do you use else if is that if it's a, let's say, possibility A and possibility B, and this is anything else. This is really A. So right here we have greater than 30. This is less than 30. We still have another possibility which is equal to 30. You get what I mean? So it's exactly 30 degrees. I mean, and here is it's less than 30. Yeah, 30. And over here it's greater than 30. So yeah, so if you have, let's say, 3 possibilities or more possibilities, right, then you use else if. But then if you find out that whatever you put in else if is basically everything else, then there's no point of else if then. So right now it's less than 30 because definitely we set it as equal to 39. Let's go ahead and set this equal to 30. Compile, run, and you can see it's exactly 30 degrees. So what happened was we checked this condition, failed, so this block did not run. Then we checked this condition, failed, so this block did not run. And then we come to the final condition because both of these guys failed. Then we come here to else, and then finally this condition succeeded. You got me? Yeah, that's basically how if statements work. So, all right, so what else? Any questions about the if statement? Okay, let's move on to the next part, which is in this case is going to be the switch case. Now, sometimes when we have, as you saw already, sometimes you have multiple situations. Like just now we have 3 possibilities for our if statement. But what if we have more than that? Well, logically speaking, you can just always keep on adding else ifs, right? But then sometimes it's much easier to use a switch case, which is another way of writing conditions in C++. And I think it's somewhere here. Yeah, so switch, which is right here, and that's the syntax. So once again, I'm going to come here. If you want to come to this page directly, just type switch C++ W3 schools. I think by now you know how to get to this page, and straight away here, and then here we go. So what I want to do is I want to actually copy this whole code and come down straight away here. By the way, I'm going to comment out all of those guys. So Control E, it will throw them all into comments. And now we are here. If you want to indent this whole block, just Control I. That will indent the whole block in one shot. So right now, this is the switch case. So what's going on here is that this is the expression, this is the test, and this are the values. So how are you going to do that? We can actually now see it again. What is that example is now? Let's take a look at it. Unfortunately, the code that we copied from W3 schools is not a full working code. It's just a way to organize the way that this thing. We still have to define, this is actually a working code right here. And in fact, let's copy this one, because this one actually is working. So what's going on here actually, I'm gonna paste this part right here. So let's zoom out a little bit. So let's take a look at what's going on here. And I'm gonna indent everything, select all, and then Control I. That will push everything into one indent. If you want to push it back, just Control U, push it back here. Control I, keep going until, but if you want to bring it back, so Control U. Anyway, so what is the switch case? First of all, I declared the variable here called integer, and the value of the day is equal to 4. Okay, and then I'm gonna the switch. Now right here, what's going on here is, this is now the condition. In the if statement, the condition was inside the bracket. Is that right? Well, similarly here. Switch, this is the case, this is the condition. So according to the definition above here, we are checking the value for day, but the value for day is equal to 4. Then what's going to happen then is going to actually go through all of these cases one by one. We don't have to worry about if statements or if else or a bunch of other things right here, right? All we really have to do is check these cases. If the value for day is equal to 1, then we are at this case. If the value is equal to 2, then we are at this case, and so on until we get to this case, all right? So let's just go, let's just try to follow the logic. Okay, so after the statement, we came to this line, case 1. What does that mean, right? Actually, case 1, literally what it means this, is, no, if case, if day, or, if day equal to 1. That's what it really means. If day equal to 1, then we are here in this case, in this situation. See, when you see the line case 1, what it really means is simply means if day equal to 1. Actually, not a single equal, a double equal, sorry. Single equal is an assigned value, but double equal is actually the check for equality. So once again, if case 1 simply is another way of writing if day equal to 1. And if that's, but since the day is not equal to 1, so we're going to skip this line, and that means this will not run. And because this will not run, this will break. Ignore break for a minute. I'm gonna skip it for now. I'm gonna come back and move on to the next one. What about case 2? Is this equal to 2? No, we're gonna skip, come back to 3, 4 until we get to here. Because this line failed, so this line also failed. So these two actually we're not gonna even come to these two lines because the case is not equal to 2. Then these two blocks will actually be ignored altogether, and we're gonna jump to the next case. So I'm gonna say that one more time. So we're gonna come here to the case 1. And we're going to check the value. Is this equal to 1? No. So we're going to skip this whole block and move on to the next case. Is the value equal to 2? Remember, the value is equal to 4, yeah? Is the value equal to 2? No. So we're going to skip everything and move on to the next case. Is it equal to 3? No. We're going to skip everything and we can move to the next case. Yes, we are here. Case equal to 4, which means that, is it asking this question? Is day equal to 4? And that is actually true, right? Is day equal to 4? That is actually true. So in this case, we're going to go inside and we're going to start to operate. We're going to actually execute this line, which means see out Thursday. And then after that, you will see something called break. So what is going on here? We already found the case we were looking for. Is that right? We have 7 cases. Is that right? And you can see that the value of the case is equal to 4, right? So if, let's see, I keep going after that. Is it 5? No. Is it 6? No. Is it 7? No. So there is no point of testing anymore because we already found the value. Is that right? And that's why if you are here and you found the value you're looking for, you would want to write a break. And break simply means, oh, thank you very much. We already found the value we were looking for, or we already found the case we were looking for. Exit the switch, or exit the switch. Yeah, exit the switch construct, or exit the whole switch block. What is the switch block? This whole thing. Okay. So what does it mean by that? See, when you go inside the switch block, you are looking for one individual case. As soon as you find it, you will execute whatever command is there, and after that, you're going to exit the whole block. So there is no need for you to test the rest of the cases. Is that clear? Is that point clear for everyone on how the switch block works? Any questions about it? Okay, so I'm going to move on. So is it a mistake to remove the break like this? Can I run my switch case like this without breaks? Can, but then your program will not be efficient. Your program will always check the 7 conditions, every one of them. Even if let's say we found the value we were looking for, even though you found it, it's still going to continue and check the rest. Now, if you only have about 3 to 4 cases, that's fine. But then if you have, like, let's say 100 different cases, then this could be a very inefficient code. But that is why it's always a good practice to check for breaks. Now, another reason why sometimes we don't use breaks is in this particular example in front of you, we are checking for the day of the week. So if it's already Monday, then it's definitely not any other day, right? So it's always a unique value. But sometimes when we check for switch, sometimes the values is not unique. Like, for example, I'm checking for my students who are currently registered. So maybe this guy is registered, paid the fees. Maybe this guy paid, this guy paid, this guy paid. So 3 people already paid, but then the rest did not pay. So then that is why it's useful to check every student. Because in this case, I will go one by one. Even if I find one student that is valid, let's say one student who already paid the fees, okay, that does not mean that the rest did not pay. Because sometimes it's not unique. Sometimes we need to find more than one answer. Is this point clear for everyone? The reason or the point of using break or without break? Okay, so here we go. Let's finish this last hour. Once again, I'm going to be moving quickly. Can you guys hear me? Is my voice clear? Can you see my screen?
Yes, sir.
Okay, so now we come to the point where you have to sometimes reuse your code. And this is one of those features where you'll have to establish in your program. Sometimes, actually, this is one of the things that I'm going to evaluate in your program. If you are repeating your code needlessly, if you're copy-pasting code, that is actually a weakness. If I notice that you are copy-pasting number of lines and you're literally copy-pasting it, then you could actually lose points. That's actually really true. So that is why whenever needed, you will have to always implement one of those situations. If you need to repeat your code over a range of values, then you use a for loop. If you need to repeat a condition, repeat some sort of code based on a certain condition, then we use a while loop. And if you want to repeat a code whenever you want, let's say whenever it's called, then we use a function. And finally, libraries, you've already seen it. Let's get rid of the libraries because it's the easiest one. You have already seen libraries already. This right here is a library. By the way, if you wanted to run a C++ program without it, that's fine, but then you won't have C out available. It won't work. You can still do mathematical operations. You can do a bunch of other stuff, but then if you want to display a value output, then you wouldn't be able to do so. So that right there is a library. However, this library, okay, here's another library, which is include and then CMath. And right here essentially is also is another library. Why is this not red color? I did not spell include correctly. So include, yeah, here we go. So include CMath, so that's another library. And then I think we There was another library we used in another example earlier. I forgot what it was. But then the thing about all of these libraries is that you did not need to install anything else. We did not have to go and download from the internet a program and then configure it. None of that was needed because all of these libraries, input-output stream or CMath and a bunch of other stuff, these are all what is called core library. Core means it comes with the core installation. When you install the C++ compiler, it comes built in with a bunch of libraries that are available for you. In fact, you can go to the C++ definition or documentation and you can find out what else is available. There's plenty of libraries out there. Now, sometimes you want to include a library, but it was not written by the creators of C++. It was written by somebody else, by a third party. We don't use any of those in our example, but we will use those in Python. But sometimes when you include a library that was not installed with with C++ or with math, let's just call it something else, right? So that something else was not available in the core, then in this way you will have to download it separately and then configure it separately, and only then you can come here and write include. And this is something that we will do in Python, but not in C++. In C++, I can assure you from now that we will always only going to use core libraries. Later on, when we do Arduino, we'll be working with the Arduino IDE, and the Arduino IDE has its own built-in mechanism for incorporating libraries. So we will deal with that in a later video. But for now, for C++ in general, we will only going to work with core libraries, okay? But the process of including a third-party library, you will always involve downloading that library onto your computer, the same way we downloaded GCC and Python. Download it to your computer, install it, the same way we installed GCC, and then it will. You have to make sure that you download and install it in the right way, in the proper way, so that your GCC compiler would know how to find it. And then you'll then be able to use that library. So that extra step, we're not going to go through when we are working with C++. We're going to do this when we are working with Python and later on in Arduino. Okay, so that actually covers the part about libraries, because you have already seen how libraries work. If a library was available to you, then you can already use its features. We saw that already when we worked with the math library. And you already saw that when we worked with the IO or IO stream library. See right here, if we go back to this library right here, if we remove it, then cout will not work. In fact, you can try it right now. I don't have to run the program, just have to compile it, and it's going to fail because it tells me now, hey, what is this cout? Cout was not declared. I don't even know what you're talking about. But if I just do this, then something else is going to happen. What is that? Oh, these are just warning. Actually, this is successful. These are warning because I did not use these variables. So the program actually worked. So if I do this again, the program runs successfully. But if I just remove cout or remove the IO stream, then it's going to tell me, hey, cout was not declared in this code. By the way, if you see this error in the future, something was not declared, then you immediately should know that, hey, there is a missing library, or I have not declared the library correctly. Okay, what else? By the way, do we need to use this? Let me check. Yeah, that is actually something that we need to use, so let's not, catch out this part, or just not mess with it. Yeah, it runs fine. So libraries essentially is a code that we'll have to download, code made by others, and then essentially we use it and call it the same way we worked with it. So let's talk about for loops. A for loops, I know I start with a while loop. Yeah, a for loop essentially is right here. And you know what? I'm gonna go and get it from the web directly. So for loop C++ W3 schools, and you know the drill. Why I like W3 schools is because it's more convenient. And here we go. So essentially, this is a working code. So what's going on here is that essentially I'm, so right here. So this is the program again. This is the for loop. Essentially, what's going to happen is This is the statement of how you write a for loop. Simply the word for. For what? What exactly? For this range of values. What range of values? What are you talking about? Well, we're going to start with the first value, which is an integer that's starting from the value of 0. And then we're going to keep going until while it's less than 5. And then we're going to increase we're going to increment this by 1. So what does that mean? We're going to start by this step right here with I is equal to 0. And we're going to run this command once. And what is the command actually? It's going to print the value for I, which is the number 0. And then it's going to finish the step and then come back again and then start again the loop. That's why it's called a loop. It's going to go back in a circle, in a loop. Now, after you finish one step, this will activate, meaning it's going to increment by 1. So the next time you come back here, the value for I will not be equal to 0, it will be equal to 1. Then it's going to check the condition. Is 1 less than 5? Yes. So then it will execute. So then it's going to print the next value, and then it's going to come back here again, then start all over again, and then increment. Once again, it's important that you follow the logic. So I'm going to actually write it down, to be honest with you. So what is going on in the for loop? So even though that you should learn this before, but it's fine. So let's do this now. So start with I equal to 0. Check if I is less than 1. I is less than, not 1, 5. Then if yes, run the block. Run the block. What do you mean the block? This is the block. Right now it's just one line, but if there was like 10 different lines here, then the whole 10 lines would run. If yes, run. Then after you run them, if yes, okay, okay, here we're going to put this in a different line here. If yes, run the block and increment I. What does that mean? So I'm going to start from the beginning. The beginning is right here. I is equal to 0. Okay, we're going to check. Is 0 less than 5? Yes, that's true. So in this case, increment. You know what? Let's do this first. No, actually, we run first and then we increment. Yeah, because we run the value, we run the code with current value of I, and then increment I. Yeah, that actually makes sense. So what's going on here? We're going to start with a 0. Okay, that actually has been defined as equal to a 0. Okay, is 0 less than 5? Yes. Okay, if that's the case, run the block. Okay. The value of I is 0, so this is going to print out. Okay, good. After you reach the end of the line, increment I. So the value was 0, it became 1. Okay, so we come back here again and check the condition. The value for I is 1. Is 1 less than 5? Yes. So that again, run the block again. And now the value is equal to 1. Then again, come back to the end, then increment to 2. And then repeat the process and keep on repeating until we have reached the value of 5. Is 5 less than 1, less than 5? No, it's not less than 5. If that's the case, we exit the loop and we are done here. So see out, I'm gonna put we are done. Okay, so that's basically just to indicate that we have exited the loop already. And you know what? I'm gonna add something else in the see out. So I'm gonna come here and say see out. Say we are still in the loop. Okay, and then add an end of line here and a semicolon. Don't forget this is C++. So what's going to happen is that now when I say run the block, simply means to run these 2 lines. So this guy right here, we will see like 5 times or something. So we're going to start from 0 all the way until we get 5 equal to it. Is there a time function for C++? Time C++. Yeah, there is a time function. That's awesome. So there is actually a library called time right here. So actually in time, I think there is something called wait or delay. Delay C++ time. Let's go. What I'm doing on my other screen, I'm actually doing this. I want to add the time delay. I know how to do it in Python. I forgot how to do it in C++, and I think for C++ 11, the solution is actually right there. So you need to include, this is one solution, but I don't like it. So I'm just gonna go, nope. Yeah, right here. So include sleep, right there. So Windows 32 in Unix. No, this is from Windows. I don't like to use Windows. Include, there is actually a function called sleep directly. We don't have a time library in C++. Yeah, there is a time right there, but it's complicated. I think I like this solution right here. Yeah, right here. So I'm gonna actually do this. I'm not sure if this is gonna work. I'm gonna give it a try. So, so I'm gonna include this library, and then I'm gonna, after every step, I'm going to sleep for 1 second. So what does that mean? It means sleeps for 1 second. Sleep is mean the loop is not going to run just like that. It's going to sleep or pause for 1 second. I'm going to run without it first so you can see the difference. Successful, and then execute, and boom. As you can see, the whole thing run really quickly. So first step, we are still in the loop because the value for I was 0. You know what? I'm going to value of I is in this. Okay, so do this again, and here we go. So the value for I is 0. We are still in the loop. Value of I is 1. We are still in the loop. You know what? I still don't like the output, so I'm gonna do one more thing. So I want to type or write a blank line after every step. So I'm gonna come and put a C out here. Just for clarity, C out, and then nothing in the line except a new line. That's it. Just like this. That actually, nothing here is just a blank line. So let's do that. And here we go. So as you can see now, value of I is 0, value of I is 0, or maybe value of I is not a good idea. So I equal, yeah, that's it. I equal 2, and I want to still in the loop. That's it. Yep, so now you can see right now, hopefully better in presentation. I is equal to 0, so we're still in the loop. I is equal to 1, still in the loop, blah, 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 until we reach 4, and then we're still in the loop. And if you count the number of steps, 1, 2, 3, 4, 5. So even though we started from 0, but we ended in 4. By the way, if you want to see this starting from 1, not a problem, we can just do this. So I changed the parameters a little bit. The first number will be 1, and then now we're going to check the condition, not just less than 5, but less than or equal to 5. Let's see how that actually changes things. So execute and run. Oh, this is nice. So the first step was 1, 2, 3, 4, 5. So this right here essentially is what they called indexing from 1, right? This is basically indexing from 1. And the earlier example was indexing from 0. So if I come here now and I put 0 and I remove this, this one now will behave just like the arrays. So when I run again, you will see that it's actually the first item, just like the array now, 0, 1, 2, 3, 4, but still 5 items. But if I want to index from 1, so I have to do this, and I have to change this to equal, and save and run the program. And you see now 1, 2, 3, 4, 5. There's no right or wrong answer, really, to be honest with you. It just depends on what you're trying to achieve. Okay, let's just go ahead and make this a little bit slower. So what if I activate this? Let's see what actually happens. So compile and run. This is awesome. You can see now how the loop is actually running in real time. Because actually there is a delay of 1 second after every step. So let's make this a little bit longer. So now I'm going to run all the way until 10. So you can see now how the loop is actually running step by step in real time as you are watching it. Later on, when we do IoT, you will see things like this because they're going to be related to the internet. And I hope by now you see or you know how to do sleep or how to do time. We had to download this library, UNISTD or Universe or something. And it's not Uni10, okay? Or it's just, I think this is standard, but I'm not sure what Uni stands for, but this is the library. and then straight away use sleep. And if let's say if 1 second was too slow for your liking, make it stop for half a second, so the loop will actually run faster. File, run, and run. Oh, what happened? Oh, it's too fast. It does not recognize 0.5 seconds. I guess the slowest we can go is 1 second. Let's say again. Oh, I think because it's expecting an integer, and then right here, actually, when you put a float, it's going to round up all those numbers going to be 0. So as if you're not sleeping at all. So unfortunately, we have to use integers. So this is the slowest. This is essentially the lowest we can go to. In Python, we can actually go half a second. So we can actually loop a little bit faster. But again, hopefully now you see what looping is. You can actually repeating the same command again and again for a whole range of values. Earlier, I run the values from 1 to 5 now, or I can run it from 1 to 10. If you want, there is another way to define the range. We can actually give it a different way of defining the range. Let me see. Actually, I don't remember it clearly. Let's just check it out. So let's go online and type range C++. Example. See if this range-based loop for C++. And example, a working example. No, none of these. No, unfortunately, no. There are ways, but you have to create an array in advance and stuff like that. But then in Python, there is something called straightaway called range. But again, we'll come back to that later. But for now, the way to declare a range is through this. By the way, if you don't want to increment by 1, you can always increment by 2. So I think you can just come and say plus equal 2. I'm not sure if that works, but that means you have to jump 2 steps. Let's check it out and see if my memory still helps. Still saves. Okay, works. Run. So 1, 3, yep, 1, 3, 5, 7, and 9, and then stop. So what happened was because I started with 1, so it's gonna jump steps, 2 steps. So 1 plus 2 is 3, 3 plus 2 is 5, and so on. So that's what happens here. This is how, by the way, if you want to find only the odd numbers, if you want the even numbers, just start from 0. And that will give you the same effect. So, oh, I didn't save. I'm still running the previous version. So compile, build, and execute, and 0, 2, 4, 6, 8, and 10. Okay, because once again, you have started from 0 and you increment by 2. If you want to increment by 3 or by 4, even also can, doesn't matter, as long as the range here is fine. So hopefully by now you see how the assign value works. By the way, I haven't done this ever in my life, so let's try this now. What happens if I put multiplication here? Probably only 1 or 2 tries will work. Let's give it a try. So compile. 0, 0, 0 will never work because the value this will run indefinitely, by the way. Because what happened is that the original value was 0, and then when you want to increment it will be 0 multiplied by 2. Which will mean also 0, so that will run forever. That's why it will not work that way. So instead, even if I started with a 1, again 1 multiplied by, and actually 1 will work. So let's give it a try. So 1 multiplied by 2, 2 then by 2, yeah, that will work. But then we'll have 1, 2, 4, 8, and ended, because after that will become more than 10. So 1 plus 1 is the original value was 1, so that's the first step. And then after that, 1 multiplied by 2, that's 2. So 2 multiplied by 2, that's 4. 4 multiplied by 2, that's 8. And then 8 multiplied by 2, 16 is already outside of the range, then we get to go. By the way, what I'm doing right now is an excellent exercise for following the logic. If you are able to read the loop and try to predict what's going to happen in each iteration, in each step, that is an excellent skill for you as a programmer, because you're combining several things at once. You're following the logic, you're doing some math operations. Of course, you're an engineer, so you have to know some math, right? And then you're applying some logical situations. So that's why and how you should always work on the loops and try to estimate, try to follow the logic. Okay, I guess this is sufficient already for loop, so I'm going to leave this here. Oh, you know what? I'm gonna just comment out all of this. And now we're gonna come and do, also we're gonna comment out this guy. And then the while loop. The while loop is actually simpler. So while condition is true, then simply do something. That's it. So if this condition is true, then run the program. That's it. Otherwise, it's not. So actually, we could have written this guy also here, by the way. We can just say, if you want, let's do that. So you know what? Let's just say int I equals 0. I'm going to run exactly the same loop from here, but I'm going to use a while loop. And then if I equal to 0, and then I'm going to do is I'm going to write I is less than or equal 10. Okay, and I'm going to basically block will be here. And then after that, I'm going to increment I. That's it. So actually, what you see here, this kind of block right here, this this code right here, let's just say put this as block, okay? And temporarily, don't panic. Temporarily, I'm going to remove those guys, put them here. I'm going to come back to them in a minute. Why is this open? Okay, remove it. So basically, what you're looking at right now, and I'm going to actually come here and do on E. So what's going on right now is that these two loops you are looking at right now, this is a while loop and this is a for loop. And this block of code, this while loop plus the initiation of the variable, and this one are exactly identical or equivalent to each other. You are doing the same work. Here's your initiation of the value. Oh, sorry, let's make that 1. So here's your initiation of the value. It's right here. And here's your test, and it's right here. And here's your increment, and its increment, we're doing it right here. So this increment, we changed it a little bit, so let's go bring it back to the original, the original increment, which is plus plus. And then the block of the code is obviously here. And we said earlier that this increment, while it's written on the top, it actually happens after you've run this block of code. You got what I mean? So to test this idea, I'm going to go back and copy the same block of code that we've had before. I'm going to put it here now. So this is the block of code that we had before. And now I'm going to remove those comments. So Control E again, and boom, we are back on track. So once again, what's going to happen here, right? Let me comment out this guy. So what's going to happen here? We initiated the value outside, and we're using a while loop. And then right here, we have the same steps that we did before. See out this, and then still in the value, and then, you know, a new line, and then sleep, and then increment. This is exactly the same behavior that we did before. And to be honest with you, whenever I use a while loop, whenever there's a condition, I don't really use for loops. In fact, to be honest with you, whenever there is a condition or a test here, I don't really use for loops. So what do you use for loops for? When there is a real range of values. We have an array. You already have defined an array earlier, and you want to loop through the array. This is something we haven't done, but it's definitely one of the reasons. In fact, I will do that in a minute. But for now, this is essentially how you do this. So I'll come back to the array example in a minute. So array, right? So right now, this is how you, let's just run this program for a minute. I mean, I want to comment out this guy. So save and run this program. Wait, we have a problem. I forgot a semicolon somewhere. Yeah, right here. So yeah. So semicolon, I forgot. So let's run this again. Yeah, we good. We good. And it's exactly the same behavior like before. Okay, so like I said just now, when I use while loops, when I use for loops, I never use for loops if there is a logical condition or there is a test. That is why I have the while loop for. So what do you use the for loops for? Well, usually we use the for loops for arrays. So I'm going to go back to my array example from earlier. So where is it? So I'm going to, yeah, that array example. And if you remember when we worked for arrays, right, when we were trying to print out the array, we were only able to print out just one item of the array. So let's say this is the string, right? And we were able to do C out, and then we will have to do this, cars, and we will have to call one item only, right? So one item, which is, let's say, item 0. Okay, and then put a semicolon here, and then run it. Yes, successful, successful, and build. And you'll see you print one item. But what if I want to print every item? I want to print out all of these things together. Well, somebody might be thinking, okay, sir, how about we do this? Well, actually, in Python, this will work, but unfortunately, C++, hey, wait a minute. It will not run. What you're going to print out or see out is the object. This concept that is difficult to grasp, but let's just call it that this is a keyword that represents this array, but not the values inside it. I think this is a good definition for now. What you're going to see out is not the values that are stored here, but just a sort of a symbol or sort of a keyword that points to this variable. So unfortunately, see out an array directly will not run immediately. Instead, you will print out some weird number. Actually, for those who have some familiarity, this is actually the pointer, or the thing that is actually pointing to the array, but not the array itself. So how do you print out those values? I want to print out every value. Well, welcome or say hi to the #1 reason why we use for loops is exactly for the arrays. So now let's do a little bit of magic. So I know that my array value right here actually is indexing from 0, right, and all the way until 0, 1, 2, 3. So until 3, is that right? Okay, so I know that my first value is 0. So, okay, here is a 0. And I know that my last value will be 3. That's it. So and it's going to be incrementing by 1. And that's exactly what it is. 0, 1, 2, and 3. That's it, right? So and then we will stop. And in this case, what we're going to do right now, we're going to simply see out. And then what we're going to do right now, we're going to simply say cars. And then we're not going to put a number. Instead, we're going to put I. That's it. And what's going to happen is that we're going to loop now. We're going to repeat this command several times. And every step, we're going to print the value for I will change. The first time we run this is going to be 0. And then after that, it's going to loop again. It's going to be 1. Then after that, we loop again. It's going to be 2. After that, it's going to be 3. And we're good to go. But for just a little bit of clarity before we do that, we're just going to print the car name is, and then the actual value, and then after that we will start a new line, and then we're going to come and do this, and then we're going to put a new line here. So this way now we're going to now print this line is going to run in every step, starting from 0 until the end, which is the end right here. Now, sir, do I have to put less than or equal? How about this? If you do that, then the last step will not print, and in this case you have to go one step further. But I would prefer that you use this because this number 3 now is exactly the last index. So what if I don't know the index? Then you'll have to check out the size of the array. This is something else we will discuss in a later time, or you can check it out on the internet. But for now, let's take a look at what happens. Successful, boom, and the car name is Volvo, BMW, Ford, and Mazda. Okay, so that's how you can actually that is the real reason why we could actually increment inside the loop. Sir, I could have done this also in the while loop. Actually, that's also possible. But as you shall see later on, especially in Python, you don't even need to do this. You can actually just write for every item in this array. In Python, this is a cheat, yeah. In Python, we can write something like this for car in cars. That's it, and that will work. That really means if every item in the loop print out the value without even need for the index. But let's not talk about Python yet, okay? So we'll leave Python for Python. Okay, so that's how we work with loops. How much time we have? About 20 minutes. So the last thing we need to talk about is functions. So we've covered the for loop, we have covered the while loop, and now we have the last part to talk about before we close the session for today is functions. And function essentially is something that you will use if you need to run the code several times. Like for example, you know what? I'm going to leave this code here. This one we don't need. I'm too lazy, and I'm going to this code right here. You know what? No. This right here. This is actually code. So I'm gonna, let's do that here. So I'm gonna actually take this guy up and put it here, and I'm going to uncomment out all of this. This one I can throw away for now. And what I'm going to do right now, and then this guy will be 4. So this will be 3, 0, 1, 2, 3. And this will still going to work, actually. See out, see out the Okay, car name, and then after that cars I, and that's it. And then a new line, and then we're gonna sleep and then iterate. Okay, let's see if that works. Yeah, it's a little bit slow because we have the sleep now. Okay, what happened to the last car? Oh, because I started from 1. I should supposed to start from 0. Sorry. So we start this again. So close it, run it. And now we have Volvo, BMW, Ford, and Mazda. Okay, so we already know that this works. Okay, that's cool and all. Now let's just say for a second, I don't like to put all of this code here. I would like to put all of this in a function. So no problem. We will come back here now. And now, okay, so how do you declare a function? Now, in the beginning of this course, or last semester, last week when we talked about variables, we said that in order to declare a variable, you must follow this setup. You have to say type, name, equal, and then value. And then later in arrays, we say type, name, and then we have size, and then we have equal sign and set of values. Is that right? Now in function, we will also follow something similar. We have type, name, and then we're going to have here something called parameters, and then we have here block. No, function, body. Yeah, body of function. Body. Yeah, that's basically what's going to be here. So body of function. Body means the actual commands that you want to do in the body of function. And over here, there's a bracket as well. So what's going on here? So essentially, for the function, you'll have to follow this. So this right here is declare function. So in order for you to declare a function, you must actually follow the same general definition that you see here. Now, usually it's not single line, but you can if you want. But sometimes it usually is multiple lines. So it would look like this. So actually there's no equal sign anymore. It's just this. And you have the bracket and you'll be good to go. So the function, or you know what? I don't remember. Let's just check it out. So here, functions. And yes, I was right. There is no equal sign. So essentially we put it here. Now, some people, they like to put the bracket like this. By the way, if you're worried about the comments, so we'll just do a multi-line comment. So like here, and this is how you close it. So this right here is a block of comments. So essentially, this is how you write a function. Some people like to put the brackets in a separate line. Some people, like me, like to put it here. That's really up to you. So the body of the function could be multiple lines. And then that's how the function could look like. Okay, one important thing before we move on. The parameters are not always there. So not always. Parameters, not always. Yeah, that's good enough. And the last thing before we end is, before the parameters end, there's something else called return value. And that would be a semicolon here. And again, this guy right here also not always. We don't always have return value. So return value is not always. Okay, so what is going on here? So let's take a look. So let's start with the simplest version of the function declaration. So this function declaration you see right here is the general type of function that you always must follow. And that's why I do not like to write blocks of comments, because of this extra star that keeps them pop up whenever you need it. So, okay, so this is now the general type of function, as you can see from here. Okay, so what's going on here is that, and I'm gonna, Control I to, so this is basically how it works. This is now the general form of the function. Any function in the world, whatever you write it like, it's generally gonna look like this. You have type, name, parameters, body of function, and then the return value. Okay, now the parameters and the return value are not always there. So I'm going to start with the simplest form of function. And that will be the function without parameters and without return value. So let's say void out show output. This is the name that I'm defining my own function show output, and no parameters. And I'm gonna put a bracket here and a bracket here, and this is gonna be my function right here. So what's the code inside? Well, basically, I'm gonna take all of this. I'm gonna basically put it here. This will not work actually. You know what? Yeah, let's just do that here. So I'm gonna. Yeah, it's not gonna work because of the I value. So let's do something else. So show output. Yeah, I'm gonna actually do something. Just a single line. So C out. Yeah, I'm gonna print something here. I'm gonna say still in the loop. Okay, so still in the loop is a statement that I want to print out, but I don't want to actually write this line. Oh, you know what? I'm going to write a bunch of lines. So yeah, I'm going to say, you know what? Int value equal to 5, and then value equal to value plus 7, and then see out this thing right here, and that's it. So that's basically this function show output. And then what I'm going to do right now, I'm going to take this command right here, show output, copy it, and then come down here. And before the increment, actually, yeah, right here, I'm going to come and do this. What's going on here is that this is now what I just did here was I did a couple of things. First of all, I defined a function. This right here is how you declare a function. Okay. And then this is basically the main program, and then this is how you call the function right here. Call function, and then here right here is declare function. That's it. So let's see if this runs. By the way, yeah, runs, and Volvo still in the loop. Oh wait, I forgot to add a new line. So let's just add a new line here. So let's do that again. Okay. So still in the loop. It's always going to be there. So notice that still in the loop will always going to print out, even though that still in the loop is not here. It's actually somewhere here. You get what I mean? But then I still anyway printed still in the loop. You know, and you know what? I want to do something else here to say, and then value. You know, the value that I just calculated just now here, right here, and then do this. So this value that I just counted, I'm going to put it here. So it has no meaning. I just want to show you that I can do some extra work. So let's see, still in the loop, and then 11, still in the loop, 11. And yes, I just wanted to let you know that I can perform more tasks or more calculations outside of this while loop. So let's just now follow the logic. Okay, this function is divide and is here, but the main program is actually this guy right here. Done in this case. Okay, so this is the main program. First, I declared this array right here. Okay, good. Then I declared a variable, and now we have a while loop, which is this whole thing. When you look at the while loop, it's a good idea to look at it all like this as one unit. So this is the while loop. So what's going on inside this while loop? First, I have a cout. Is going to capture the value of the array based on the index value. Okay, so right now in the beginning, the index is 0. So it's going to keep on capturing the values based on the index. And then we're going to sleep for a while, and then we're going to call this function. Okay, so where is this function? We're going to go up and then take a look at this function. All right, what's going on inside this function right here? So basically, we declare a variable, we update the variable, and then we print out a statement that includes the variable. And then after we do all of that, we come down here. So once again, I want to show you. So you call the function from here, it goes up there, and it comes back again. It does the job, it comes back exactly from where you left it. And then after that, it will do the increment. And once again, if I run this, notice where we do the still in the loop, and then the increment happens. You get what I mean? So still in the loop happens, and then after that, the increment. So far, so good about functions. Okay, so what else after that? So what about, you know what? I don't want to actually do all of this stuff here. Actually, I want to take everything here, right? I want to put it here, right here. And obviously I cannot do this anymore because this is inside the function, but now I want to actually run this whole code from inside of this function. Oops, what happened here? Yeah, let me just, the indentation a little bit, let's just fix it, so Control U. Okay, so basically what I want, rather than doing this whole command here, I just want to put show output from here. And the problem with this right now, if I actually call show output right now, show output, if you look at it right now, it has a variable called I. But then right now we are here inside the function. Yeah, we are inside the while loop, and then you are calling the function. So you go here to call the function. But then when you go inside here, this variable I is not declared anymore. Sir, I declared the variable here, but then unfortunately, this is now something called the scope of the variable. And I think we discussed that in the theory chapters earlier. You see, this variable right here is declared, yes, but then this variable inside is inside the function, so that's a different scope. So if you update the value here that you see right here, it will not update on the outside, so the value will always remain 0. Let's take a look and see what happens. In fact, it's not going to even recognize it. It doesn't even know what this is. You get what I mean? So because the value of cars does not even implement. Because you see, cars I, you see, we are now asking this function to look for something called cars I. But then the cars array was declared outside of the scope of this function. So that's why it wouldn't recognize it. So how do we solve this problem? By simply using arrays. So what we're going to do, we're going to actually come here and say cars, excuse me, we're going to use parameters. So this is what is called now parameters. So cars I essentially is this parameter right here. Now remember, each one of these guys is what exactly? It's a string, is that right? So I'm going to come here and write string, and then that will be the individual value. I'm not sure if this actually works here. Let's give it a try. But about 5 minutes to go, so I'm going to come here now and say, so here we're expecting actually string value, or you know what, car name. So in this case, now we're expecting something called car name. So right here, all we have to do really is come and do car name, and it's going to work. And for now, I'm going to take the increment and leave it on the outside right here. So right here, this is now, what's going on is that we actually took the value from the array, which is a string, which is the car name, and then we're going to feed this into the function as a parameter. And the parameter now is called car name. And now this car name is going to be right here, is going to be actually print out, and then it's going to sleep as usual. So let's give it a try. File successfully, build successfully, and run, and it works just fine. So let's once again follow the logic. Step number 1, we are here. We declared an array, and then we are here. So while we are under less than 3, or we are still inside the loop, capture the item based on the index number, which is based on the value for I. Okay, after you capture the value, that will result in a string. Take that string and pass it to this function, show output. And then show output is expecting a string because I already declared it here, string. And whatever string you're going to get, we're going to call it car name. And right now, car name is declared here. By the way, car name, the variable car name, is declared only within this function. Anywhere else outside of this function is not available. So hopefully by now you know what this variable scope means. So now you take this, and then it's going to print out the value, and it's going to sleep, and then we're going to return back here, and then we're going to sleep again. You get what I mean? So based on that, this is exactly what happened. One final thing to do before we close is, what about the return value? Okay, it's not a problem. So what we're going to do right now, I'm going to change this to integer. So what's going on now? Actually, earlier when you do void, void means nothing. You are simply meaning you are not giving any value. But if you want to return a value, you have to declare its type. Remember when I said variable? Actually, void is a variable type, but I did not want to talk about it in the beginning because the concept of void is a little bit difficult for beginners. So what we're going to do is we're going to actually take this guy right here from here, and we're going to increment it, and then we're going to return I. That's it. But then the value for I will have to be here, right? I think we're going to have to do this. Let's see if that works. I was not declared in this scope. Yeah, it was not declared here. Instead, you know what? I'm going to actually declare a new variable. I'm going to call it int j. And I'm going to actually increment. Oh, wait, I still need j itself. Now, you know what? Let's not worry about the increment. I'm running out of time. So I'm going to deal with the return. You can actually watch it in the videos. Okay, I think I've discussed enough on the return value in the video. So for now, we're going to stop because I don't have the time to go through it. So I'm going to stop with void, and I think this version of the program runs. So yep, runs, and runs. Yeah, so we're going to stop here. So with this, we actually covered all the functions, all the issues about functions, except maybe for the return value. We can, for more details about function and return value, you can actually check out my videos. Or if you want, you can actually see that we already have a function. In fact, if you look at C++ itself, the main function, this right here is actually a function. If you ever wondered, what is this you're looking at in C++? This is actually a function, and the type is integer. That's why in the end, you're going to have to return a 0. By the way, if you come here and write 7, for example, or any other integer you want, the program will still run. But that's not a good idea. Let's just keep it at 0 because that's the standard. Hopefully you understand now what int main mean. Main essentially is a main function that the compiler is waiting for, and because you declared it as int, that's why it needs a 0 in the end. So that actually is an example of a return function. We didn't have time to actually make one of ourselves or make one of our own, but you would find, or you could find, more examples of those functions in the recorded videos. So with this, we've covered all the contents of this video. We've talked about C++ variables, user input, operators, reused code, loops, functions, and libraries. And with this, we're now finished this refresher course on C++. I will see you in the next video where we'll talk about Python, and then we'll move on to the next section. Thank you and take care.